Welcome, ladies, gentlemen, cyborgs, but especially the cyborgs, to Voidstar Lab. That's right, we started exactly on time today. Everything is rocking. I am so tired because my dog decided one of the dogs decided to start barking his face off at 10:30 or 11, which means I only got like 5.5 or 6 hours of sleep last night, but it's no problem. I can design a circuit board in my sleep, although I'd prefer not to. It's not a very restful way to collect your thoughts at the end of the night. Oh, I just realized I never updated the bot. Oh crap. Oh poop. Oh no. What's up with all the grapes? What's going on? Why is everyone putting grapes in chat? Why are we grape posting? I gotta adjust that bot. I just realized, because today's episode is sponsored by Next PCB. What's that say there? The reliable multi-layer board manufacturer. That's right. Oh no, I have to change it. Oh, stop giving the bot. Hang on a second. Stop giving the bot commands. There we go. I'm gonna hide those. Oh, I didn't put the ask the bot headline in the thing. All right, we're just gonna have to. It's just gonna say ask the bot there for no reason while we adjust that. So yeah, welcome everybody to the stream. Today we have something very special for you, because for the first time we're gonna be. Yeah, because for the first time we're gonna be laying out a circuit board. So yeah, what's funny is that. Most of the channel, most of what we've built on the channel so far has been 3D printing related, right? We've been doing a lot of modeling, we've been doing a lot of printing, we've been doing there's been a fair amount of soldering and hardware hacking, but never any board layout. And what's interesting is that before I started the channel, laying out boards was one of the jobs that I did most often. Most of my projects have involved designing and laying out circuit boards. In fact, I've actually laid out a number of boards since starting the channel, even though none of them have been for the channel. Anyways, the reason why I haven't done that is because the process of getting circuit boards made it's not a time-consuming one, but it is a long one, right? You have to figure out what parts we want. We have to design a schematic. We have to convert the schematic to a board. We have to order the board, receive it, populate it. If there's a mistake, we have to spin another revision. And even though I've done that, even though I've designed dozens of boards, maybe even more than 100 at this point, it doesn't fit the aggressive schedule that we need for YouTube. So what's changed? Nothing. Nothing. We're just doing it anyways. This is really, in a way, this is why I started streaming in the first place, because it allows us to do projects that take longer than a video, right? Because we can split the work because we can create content across multiple weeks. And that enables us to do stuff like lay out boards, and now we're going to flex it. So yeah, today we're starting our Cyberdeck project. I know I've been selling this as a mechanical keyboard, but that's not entirely true. It's also a Cyberdeck and a mechanical keyboard. Allow me to explain. So I'm sure everyone is familiar. If you're not, you really should be. Oh, have I left this? Wow. Hopefully you're familiar with the Cyberdeck project. And I realize I've left it on all night because this thing has 2,500 milliamp hours of battery. So it can run for 24 hours. Anyways, I built this Cyberdeck for a past episode. It's based on the Raspberry Pi 400. And I promised to make a sequel. And I've promised a lot of things in videos, but this time we're actually doing it. So, oh yeah, by the way, if you're wondering, the thumbnail, the text was actually I wrote it, but instead of putting it directly into Photoshop, I loaded it on here, and then I just took a picture. So yeah. Anyways, let me shut this off real quick because I want to conserve what little battery power we have left just in case we need it. Yeah, so we're making the sequel to this. And Yeah, what's our this project's kind of taken on a life of its own because I used a Pi 400, and it makes it one of the few projects out. So yeah, I used a Pi 400 because I thought it was cool, but it turned out to like give the project a life of its own because there weren't that many people making projects with the Pi 400, but we're not doing that this time. Making it with a Pi 400 has a real problem, and that is that the Pi 400. So like the Cyberdeck, by the way, it works great. I really like it. We actually used it a lot for my for when I was designing the when I was building the Ultimate 3D printer. I recently declassified those streams. You should watch them. They're pretty good. That project has been working really well. I'll talk about that more later. Anyways, the problem with that as a project is that there aren't any good ways to mount the Pi 400 to stuff. It wasn't really designed to be put into projects. It's kind of a standalone device. And that's why I never released it. Because in order to keep the thing together, we've had to glue stuff. We had to glue the Pi 400 in permanently. And that has major problems. It makes it impossible to repair. It blocks some of the ports. It makes it next to impossible to replace the SD card. It's just not an optimal design. So we're going to do it right this time. And yeah, we're basically, so the project today is we are going to make a Cyberdeck. Sort of. Yeah. So I realized that Cyberdecks aren't for everyone. So let me train the bot here. We're making a mechanical, let's see, we're making a mechanical keyboard that doubles as a Cyberdeck. And that's exactly what we're doing. And there's a certain hidden command here that I also need to edit. Let's see, not. There we go. There we go. Okay. So, yeah. So here's the plan. Let me give us our commands back. There you go. All right. So the plan today is kind of twofold. The first is we need to think about the nature of the Cyberdeck. Figure out, like, just do a little thinking about it. Strategize a bit. And then we're going to get started designing the wow, I'm very tired. Then we're going to start designing the circuit board. This is not, we're not going to finish this today. This is going to be a multi-part project in actually 2 parts. We're going to be doing a few streams now to design some of the circuit boards. We're going to order the boards. We're going to put this on the back burner while we do other stuff because it's going to take time to actually fabricate all this stuff. And then we're going to revisit this project next month to go through the basically to do the actual assembly part. It's kind of the nature of making a circuit board. Whenever you're doing a project that involves boards, you have to count on this bit of inactive time. And yeah, your schedule can basically get ripped in half if you're not diligent in the time between when you order the boards and when you receive the boards. If you have to plan very rigorously for what you're going to spend that time on. And for me, that's going to be making other unrelated videos. So let's see. We got our first super chat, Ablative Kitten. Thank you so much for kicking it off. Hello, Zackerman. How you doing today? Done anything fun? Here are the contractually obligated duck emotes. Thank you very much for the ducks and for the, I want to say for the ducks and for the bucks, but they're actually quid. Really appreciate it. Much obliged. I also have, let's see if we can do this without leaking all our info. Excellent. Very nice. And also, thank you to Evan for becoming a patron. Thank you so much for supporting the channel. I really appreciate it. By the way, if you hear the dog barking in the background, apologize for that. If he continues to bark, I can set up a notch filter to filter out the barking. We're training. Yeah, that's Edmund or Peter, whatever. We've adopted a dog. We're fostering another, and we are currently training them we're currently training them to stop barking. And when you're training a dog, or when you're trying to break a habit yourself, you have a phenomenon called an extinction burst, which is as you break the bad habit, the desire to perform the habit increases. So yeah, as we train them not to bark, they're going to have outbursts of barking like crazy. It's part of the process. The dog's all right. He's totally okay. This is natural. This is part of the learning process. The dog is a-okay. Yeah, it's just the nature of teaching him how to bark. Remember, like what we're trying to do here is we're trying to train him that barking accomplishes nothing, and kind of like as he breaks that habit, he's going to bark a lot to try to see if pushing it further will get him the result. So don't worry about the dog if it's being too annoying. We'll take a couple minutes and set up a notch filter to filter out the barking, because dogs don't have as much of a vocal range when they're barking as humans do. Anyways, yeah, let's begin. So yeah, let's just double check that everything is good. Okay, very nice. Thanks a lot to our patrons. I think the first order of business before we get too deep into this project is to take care of some older projects, because as you notice, the Chromance is broken. I was trying to update the animations. Here we go. I was updating the animations, and I kind of put the ESP32 in backwards, and that kind of ruined everything. So yeah, so now it freezes because I think the regulator overheats because I mostly blew it out. All right. Please let me know in the comments if the dog is being too annoying. I don't want to interrupt the flow to start messing with our sound settings without knowing he's actually being a problem. Yeah, let's see. Edmund is up for adoption. He just got fixed. So yeah, if you're interested in a very sweet dog, he's not the one who's barking, by the way. That's his brother Peter. If you're interested in a very sweet puppy, and you're in the Colorado area, then get in touch with the Good Dog Rescue. So real quick, let's. So I got a new stream. So I got not a stream deck. It's called the Loop Deck. Du Loop Brother. Let's see. There we go. So yeah, I got this loop deck that's going to help us edit videos a little quicker. And oh, I forgot to put on the little green rim there. There we go. And it'll also make the stream flow a little better. So let's. I'll turn that on, and here we go. We have another ESP32. So let's real quick switch over to. Let's see. Let's get this out of here and switch over to here. There we go. Yeah. So let me find a micro USB cable. Here we are. And let's plug this guy in, and let's fix the Chromance, because the show just ain't the same. The show just ain't the same without the lights going on in the background. Let's get the objects that can short out of here, because I don't want to kill another one. Let's see. Get these here. There we go. Oh, look at that. Oh, look at that. Very nice. All right, so we want. Let's open up Arduino, because that's how we're doing all this. So as for the mechanical keyboard, I'm getting a lot of questions about how I plan to do this. And the truth is, I don't know. I've been so overwhelmed with other I'm committed to the schedule, but I've been so overwhelmed with other streams and other projects. I haven't put a single iota of thought into this. So we're going to be designing this together. It's going to be part of the fun. Hey, we got another super chat. Francis Usher, thank you so much for the super chat. 40% gang in the house. I'm not sure. I don't think we're going to be doing 40%. I think this is going to be closer to 60%. I say closer because, as you'll see, we have a few knobs we can turn that are unique to the Cyberdeck form factor. Yeah, that's going to be fun. But I really appreciate the super chat. Thank you so much. It does a great job of supporting the channel. I really appreciate it. And thanks to everyone, by the way, for your patience. I know the next episode's been taking a while to. It's been taking a while to pull together, because there's just a tremendous amount of stuff going on. Dog's been throwing extra stress in there. Personal things going on. None of that's relevant to you. I get it. The next video is in the works. It's going to come very soon. Thanks a lot for your patience, especially for all the patrons. I really appreciate your patience. We're getting a lot of stuff moving to try to improve the channel, because I just don't think the thing's been going the way I'd like it to. Last stream was just a complete disaster. Yeah, last stream was a total mess. That one was the worst performing piece of content I've ever produced. So we've kind of reevaluated everything, and we're going to be Yeah, now things will move smoothly from here on out. We're going to make this a lot of fun. So real quick, I'm just going to upload our Chromance firmware to the, here we go. Upload the Chromance firmware to our new ESP32, and then we'll go in back and just quickly swap that out. If we blow it up again, don't worry, we got 4 more where that came from. These things are really cheap. These things are really cheap. Amazon had them on sale, so I bought a whole pile of them. Friendship with Teensy ended. ESP32 is best friend now. Speaking of, what processor we're going to use today is kind of an interesting question, because I'd love to use a Teensy, but it's not practical for this project, because we want to try to keep, one of our main constraints here is we want to keep the profile as shallow as possible. We want to keep this thing thin, because it is a portable device. And a Teensy, we'd either have to use a Teensy module, right, like the Teensy itself, and put it on the board, which would increase the height. Or we could integrate into the board, and I'd love to do that. The problem is it's not very easy to get a hold of the pre-programmed bootloaders, and they're leadless components, so they're actually kind of difficult to solder in. So I don't think we're going to use a Teensy. The obvious choice is the Atmega 32U4, like the same one as the Leonardo and whatnot, which is an all-right choice. I'm not totally jazzed about that because of how expensive they are. They're a bit spendy, and honestly, they're kind of hackneyed. You know, like they're kind of done to death. Wait a second, are these different? What's going on here? Are these different? Oh, they are different, huh? I thought they were the same because they look so similar in pictures. Here, yeah, I thought they were the same because they look so similar, but. Yeah, here, take a look. So this is the one we were using before. It's a Node 32 clone, and this is the one I bought. It says ESP32 Dev Kit 1. And I thought they were the same because they look so similar, but this one has far fewer pins than that one. I don't know what's going on there. So, all right. Oh crap. I guess we're not doing any Chromance today. Ain't that a bummer? Up, not that, not that. There we go. Well, ain't that a bummer? Okay, so let's move on and let's do our selecting parts. So we have a couple decisions to make here. First, we have some decisions to make with the Cyberdeck itself, because if things like the screen size will determine kind of like what size of keyboard we can use. That's why I said it might be a 60%, it might not. I already know what keys we're going to use. Here, allow me to grab those. We are going to be using. Here they are. We're going to be using, for keys, the Kale Chalk keys. There we go. These are low-profile mechanical keyboards that have I really like the feel. I have the brown ones here. I couldn't get a hold of them. Mine is going to have the clicky keys, but these are available in there are 3 versions of this. You have the clicky version, this one's the tactile version, and you have the linear version. And the last 2 are very quiet, which is nice in a device designed for hacking. And the clicky one is nicely tactile, and you can see that the form factor is quite like it's pretty shallow, and more importantly than that, the little the keycaps attach differently to these. They have these little prongs, and I think those will be really easy to make on a resin printer. So oh wait, no, here we go. I do have the clicky one. Here, listen to this. Isn't that a satisfying click? And it's such a thin key. Here we go. Here's a box jade to compare it with. Let's grab these from the back so you can actually see what the heck I'm talking about. So these keys are like, not only are these keys, we're gonna get double vision for a sec here. So not only are these guys like a third as high, but the keycaps are also like a quarter as high. So these are going to make a very low profile keyboard. Here we go. Very nice. Yeah, and they're nice and clicky. And the keycap attaches to the top of these little prongs, so we should be able to print them easily, which is really nice. So we're going to be using these. I believe the footprint is the same. No, they have a different footprint. So we may have to model that ourselves. I think we'll be able to find them. So we've already got this guy locked. We already got this one locked in, and we're going to Yeah, so some other things to consider. First, what microcontroller we're going to use. I'm gravitating towards 32U4, although I'll accept suggestions for other USB-enabled microcontrollers. The second thing to do is get a rough idea of layout. We'll do a little shopping for a screen. I want to get an idea of what size envelope we want to be in. And also, another thing to decide is if we want to matrix these keys or if we want to use an I/O expander. I'm actually gravitating towards an I/O expander for two reasons. The first one is it'll reduce the amount of time it takes to build this thing, because instead of having to give each key its own diode, all we have to do is, like, the whole keyboard is going to have, like, the keys plus, like, 6 supporting parts, and I like that a lot. Second thing is, I'd like this to be a split keyboard. And this is going to be a little weird, because it's a Cyberdeck. It doesn't make any sense. But trust me on this one. We're going to make this a split keyboard, and the easiest way to do that is to give each half its own I/O expander, so you don't need to put two processors in it. So if it comes time to update the firmware, put new key mappings and whatnot, you don't have to update two microcontrollers like we do with my Ergodox. You only have to update one. What's up with the split keyboard thing? I'm glad you asked. I know a Cyberdeck isn't for everybody, right? Like, it's a pretty niche device. Oh, people are saying my mic is clipping. Well, that's no problem. I can lower the volume right here on my Stream Deck. Ha ha ha. Thank you very much. Sorry for blowing out everyone's eardrums. There we go. Yeah, here we go. I'm still getting a handle on the you know what? I'm going to pull this. I'm going to adjust this here. I'm still getting a handle on this equipment. We're running a bit of... There we go. Mic check, mic check, mic check. Test, 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 test. There we go. I'm running a bunch of new equipment. So I appreciate the patience, but as you'll see, I think it's going to be worth it. We'll look at some other neat additions to the streams in a sec. Yeah, I know, by the way, just real quick, I want to address that I'm really happy to see so many people here. I really appreciate you being part. The truth is, I just really like doing the streams, and I know that's not a common sentiment in the channel. I've come to it's been shown to me unambiguously that the streams are a bad idea. Most people don't like them. So I appreciate you being here. Over time, we're going to start migrating the streams to Twitch. But for now, like, we're going to stick to YouTube. We're going to stick to YouTube. In order to move things to Twitch, I need to make a number of videos in close succession so I can tell people to go to Twitch. Because, yeah, we're going to lose most of the viewership by going to Twitch. But, yeah, I appreciate everyone who's here. So, yeah, let's get going. So, yeah, let's get going. So the first thing I want to do is just do a little shopping for displays. We're gonna do that at AliExpress, because there's no... did we talk about Next PCB? All right. Oh, yeah, we briefly touched on it. Today's episode is sponsored by Next PCB. They're an overseas PCB manufacturer who has... I'm really impressed with not only the quality of the boards, but also the quality of their service. I know some PCB services really bare bones, but they offer the same like automatic DFM. They tell you if there are design mistakes instead of just like you make your order, say like, yeah, we could do that. You make your order, you're like, where are the slots? No, they give you a full rundown. They have tons of options. The prices are reasonable, and the turnaround time is very quick. It takes like one of the reasons I haven't really used any of these overseas manufacturers in the past is because the turnaround times and the shipping can get kind of insane. Like, I'm pretty sure for some of these, it takes a week or longer to actually have the boards fabbed, and then a week or two to get them to you, and that's far beyond what I can do. These Next PCB can have your boards done in only a few days, and then they can ship them express, and yeah. You can actually, they actually can do quick turn services too. So if you need your boards in the same week, they can do that too, which is really impressive for an overseas company. And they also have a service called Next DFM that basically gives you the same DFM tools they have. So you can basically you get to run their tools in advance to make sure that your design is going to look right, that can be fabricated and all that. You can download that for free right now. Check the link in the description. They're offering a really good sale. Like, they're offering discounts of 20 to 30%. So, Yeah, definitely. We're going to be using Next PCB to order the stuff for this project. But I urge you to, if you have a project in mind, feel free to run it off with them. They have a lot of introductory offers and make it super easy to jump in. And yeah, thanks a lot to Next PCB for sponsoring. Let's go. Let's take a look at some screens here. So the search term we want to use. So like for the, I'm going to keep the Cyberdeck handy because we're going to be using this thing as reference. Here we go. So, yeah, here we got our Cyberdeck. So you notice it's got this long display on it. I really like I like this form factor, but this particular display has a couple problems. The first of them is, oh, there we go. The first problem that that display has is that it's very small. It can't fit a lot of stuff on it. The 1280 is good. The 480 isn't. Things aren't really designed to run at such a small resolution anymore. The reason why we're doing this now is because by getting an idea of the size of our display, it'll give us an idea, of the size of our keyboard. So we're not going to necessarily select a part right now, but I do want to see what's out there. So the keywords we're looking for here is stretched bar LCD. These were initially designed to be used in store shelving. For labeling and as rear view mirrors. Like, they're the size, so these are approximately the size and shape of a rear view mirror because they're used for rear view mirrors with backup cameras. So we want something slightly bigger. This is the exact one I got before. By the way, I really like this display. There's no business relationship here between me and OI's Coco, but I just really like this display. It's apart from the weird resolution that requires you to edit config.txt there are a couple weird things about this display. The first is weird resolution. You have to update config.txt. The second weird thing is that they're showing this as landscape, but it's not. This is actually portrait. So you actually need to do a little finagling with I forget what it's called. X input. You have to do a little wang jingling with X input to turn the touchscreen 90 degrees. Touchscreen works fine out of the box with no drivers, but it's rotated 90 degrees. And what's weird is that you can only rotate the official Raspberry Pi touchscreen using config.txt. You have to rotate other ones using X input. It's not hard. It's just a kind of a gotcha. So I like this a lot, but the size is a little on the small side, and the resolution is a little low. So I want something a bit bigger. What I do like about this is the touch screen. I like the fact that we can touch it because it means we don't need to add any pointing devices to this. We don't need to add a mouse or a trackpad or anything. I'd like to. So another thing to keep in mind is the size of these because they all look the same. But this one is 44 square inches. Let's up our font size a little. This one's 44 square inches. This one's 30 square inches. Or, not square inches. I mean like diagonal. We want. The last one was 7 inches. We want ours to be a bit bigger. I left a void on the side of it, so if you see the display doesn't go all the way to the side. I left room for this heads-up display here, and we're not gonna do that in the release version. I don't expect people to go out and buy heads-up displays. So I want one that goes coast to coast, or at least close to it. So let's see what we've got. Let's check this manufacturer's page because this site the supplier Wise Coco. I really like the driver board. That's one thing I hope we can get because one thing that I really like about this display is that this is it right here. This is the driver board. That's all. So all we have to do is connect power, HDMI, and we can also do audio. This is a really nice design. It's just in one board. It sticks to the back. See, like. They have a different picture here. It sticks right to the back of the display. There we go. Yeah, check that out. It sticks right to the back, and you just connect the three lines. The HDMI is just HDMI. The micro USB both powers it and drives a touchscreen, which is really nice. And this board sits right in the back, so it's a super slim profile. So I really hope we can get away with getting another copy of this. Plus, it even has an amplifier and whatnot for the audio. It even pulls the HDMI audio out of the HDMI line and converts it to line output, so you can just plug a headphone in there, which is nice. I was supposed to have done that with the last Cyberdeck, and I didn't. Akelia says, share a picture of the doggos. Also, hello, Brooke. Hi, Zack. Happy stream. We could take a little doggo diversion. Let's see if I should already have my camera uploads going because I have because I've been working on the next episode. Next episode is almost it's more or less done. Mostly needs here we go. Next episode's more or less done. I just have a little bit of busy work to do. So let's take a little bit of a doggo break. Let's see. That's Ross. There's Roscoe. It's oh, here we go. Let's see some doggos. Oh, this is when we reunited the puppy brothers. This is when we brought Edmund back. They had been.
That was a puppy moment.
It was a puppy moment. Yeah, they were broken up at the shelter, or at the doggy death row. We rescued Peter, but it turned out his brother also needed to be rescued. I don't know why the resolution for that one was so low, but yeah, they're very good boys. They're very good boys.
Oh, look at that puppy who just had his first bath.
This is Edmund immediately after getting his first bath. Look at that fur. This guy smelled so terrible when we got him. He was such a stinky puppy. And then finally, this is what we're hoping for this stream. Sleepy puppy and sleepy wife. Look at that. Look at that sleepy puppy. Ah. Anyways, yes, that was your daily puppy moment. Let's build some stuff. So this one is 7 inches. This one is also 7 inches. Let's check out the Let's check out their page real quick and see what they have in a larger size. Let's see what they got. So what we want is 8 to 15. We don't know the exact size here, so I can't check with that. It might not. I mean, this product might not even what we're looking for might not even exist. You might end up having to use the same display. So we'll end up. But yeah, we'll check for a couple minutes because it's important to have an idea of what size we're making. So what's going on here is the keyboard is going to serve double duty. It'll either become. How do I get to the supplier's site? Why am I having such a hard time with this? There we go. This site's not easy to use. So you'll either be able to install the PCB within the Cyberdeck to use as part of a Cyberdeck, or you'll be able to just put an enclosure around them and use them as a regular As the
keyboard. One of world's leading display solution supplier, Wise Coco not only has diverse.
Anyways, yeah. So what I'm thinking is when it's in an independent keyboard mode, I'd like this to be. Oh, that's neat. A double display module. I'd like this to be a. Oh man, I'm so tired. I'd like this to be an ortholinear split keyboard, and I know that they exist. I know this has been done before, but I still feel like at least giving people the option to make this a different way is going to be of benefit. So that's why I'd like to have this independent. Oh, look at these flexible displays. What do you? That would be kind of neat, wouldn't it? Like to have a flexible, like a thin flexible display. I don't think that would help at all. I don't think that would actually give us anything. So here's an option here: a 12.6 inch display, but this has a much larger driver board. I'd prefer to have a more fully integrated one. Here's another option. This looks like a self-contained device here. So this is actually a self-contained device. This isn't like a bare board, but nothing stops us from just stripping the board out. It looks like it has 2 HDMI ins. That's interesting. I don't know how we would use that. But I mean, we know it's the right size here. We could try getting in touch with the manufacturer and see if try getting in touch with the manufacturer and see if they'll just sell the innards, or if they'll tell us what the SKU of those is, what the how to find it on AliExpress. AliExpress and whatnot are not the easiest sites to search. But this is approximately what we want. Oh, this is cool. These are often used for case mods to show to show stats on it. That was originally what I was going to do with the other one, but I just didn't have a good place for it. The other display, by the way, ended up the other one of these displays, if you're curious, ended up in. Here we go. There's my sandwich. There's my breakfast. It ended up being the control panel for the tool changer. You see that down there? Yeah, check that out. So that's what the other one ended up doing. The third one that I got was destroyed. because you know my advice. Whenever you're buying components, you always get 20% more or 2 extra, so that you have spares when things break. Note the phrase when, not note the word when, not if. So this is an option. This one's 12.6 inches. So yeah, let's just do a quick size comparison here to get an idea of how, because like I think that's about what we want. This is 7 inches. So let's see. So this one's about 7 inches. So let's get this ruler is 12 inches. So this is slightly larger. Yeah. So this one would be slightly bigger. Not the end of the world, though. One thing that I'm considering doing here is adding in some slots. Remember the Singularitron? Like, it's got the Singularitron's got these little cartridges that add features. So I was thinking of adding some of these to the Cyberdeck. I think that would be kind of cool. Be able to slot in new sensors and stuff. So this is an option. This might be more what we want here. This is 9 inches. I think that's more what we're looking for. But this one doesn't have a touchscreen. Yeah, let's see what we got here. 8.8 inches, 1920 by 40 capacitive touchscreen IPS module. So yeah, see the with the enclosure, it's just kind of thick. See, it's 20 millimeters with its enclosure. So the question is, what's going on inside? If we rip the electronics out, how small are they going to be? Because we don't need the enclosure. We're gonna be adding our own. Size is really important for a Cyberdeck. I think a lot of people underestimate just how thick Cyberdecks are. If you go into a project like that without putting a lot of thought into how you're gonna make it small, you're going to end up making a very thick device. Here's what we're looking for. I think this is what we want. No touch kit with touch kit. Is this? Oh, yes, this is already installed. Okay, so I think this is what we want here. Is this also the same brand? Yeah, this is the Wise Cocoa. These fake brand names are they just get me. I think they're hysterical. This doesn't look right. This bezel should be bigger. But 9 inches, I think, is the way to go. So 9 inches on the diagonal. What's our resolution here? Let's see. Resolution. Where is our resolution? Another thing I don't like about... Yeah, alright, so this is a little on the thick side. I think that's fine. Yeah, it's going to be about the same. Okay, here are dimensions. 231 millimeters. That's about as wide as the... 230 millimeters. It's going to be about as wide as the Raspberry Pi 400. So I think this is our... Yeah, it's going to be this wide. That's our size. We could make it's going to be a little... We could make a keyboard that's actually slightly larger than 60%. Oh, check that out. We got we got amplified speaker outputs. We have micro USB with the touchscreen. We have HDMI. I'd prefer not to do HDMI if I can, because does this give us our backlight as well? Let's see. Probably. I see an inductor here. It says 6R80 though. That might not be an inductor. I think it looks yeah. I've definitely seen some inductors here, so I'm guessing that's yeah. So I think this is our boy. I'm going to bookmark this real quick. Bookmark that, not in the filaments. Hardware hacking reference. There we go. All right, so this is what we're looking for. So we're gonna try to make this in the neighborhood of 230 millimeters wide. All right, very nice. So the next step. All right, so yeah, that's what we want. We've decided on our parts. Let's think. What else? Processor. I don't think we need to pick the processor right now. I think we should design the key matrix first and then move on to the processor. It's been a while since I checked chat though, so before we dive too deep into that, let's take a look. Let's see what folks are talking about here. Trevor Flowers says Keebs. Yes, indeed. I think I follow Trevor on Twitter. Welcome to the show. Anthony says flexible Cyberdeck. That would be nice. The problem with building flexible electronics is that there just aren't enough electronics that are flexible. You can get, like, some stuff. You can get circuit boards that are flexible. Now you can get displays that are flexible. Can't get batteries. Can't get chips. Can't get keys. Can't get all kinds of stuff. Eris Palm says, why would you want a larger than 60% split keyboards? Are you actually using all your keys in the ergodox? I absolutely am. I totally am. Every one of the keys on this thing gets regular use. Remember that... for the purpose of the Cyberdeck, remember the number one thing we're doing with the Cyberdeck is using the command line. And to use the command line, you need a lot of symbols, right? Like if all you're doing is writing text for the most part, or even to an extent code, but basically if you're writing a lot of text, you don't need, a dedicated open bracket, close bracket. But if you're doing a command line, you certainly do. You need a lot of keys. JB, a few people are asking, Zack, got any split board suggestions? I got wrist issues. I think that's what we're going to be making here. Chronome says foldable split keyboard. That's exactly what I'd love to do here. If we have the time, I'd like to set this up so that you can fold this thing if it's in keyboard mode, because it's going to be low profile. Andrew Kahn asks, why do inductors matter for the backlight? All right, so they matter basically because a backlight they're LEDs, and LEDs are current controlled devices. If you've used LEDs in hobby projects, right, you're used to using a resistor. But that's not what you want to do in a commercial product, or really any product that is supposed to withstand close scrutiny and extended use. Because don't look at my sweaty pits. Because the amount of current going to an LED affects its brightness, and even a small change to the amount of current can have a real impact on brightness. So in a commercial setting, you want to use a backlight driver. You want to use a chip specifically designed to pass a steady amount of current to a string of LEDs. And those are almost always buck regulators because, I don't know, for probably efficiency reasons, but also because you need to generate a higher voltage than the voltage coming in, but you need to regulate that very tightly, and buck regulators can do that. So it's likely that the backlight driver is on board because it has parts for that. Yeah, it's an interesting question. Let's see. Famatory, let's see. Let's answer another two. Eris Palm says, we use the command line a lot in 44 key Atreus. I suppose you're not the type who uses a lot of layers. I don't like using. So layers mean basically the fewer keys when you have. Layers are really easy or layers are pretty they're one of these mechanical keyboard concepts that sounds crazy, but you actually used it before. Think of it like how there's no exclamation point in your keyboard, right? You hit Shift 1. So if you want to use a smaller keyboard, you just stack up more of those. For instance, you get rid of the function, like on this keyboard, right? There are no function buttons. Instead, I hold this button, and now the number keys are function buttons. You can take this a step further and get rid of the number keys. And now I hold down a different button, and it shifts, QWERTY into 1, 2, 3, 4, 5, 6. And that lets you put more keys on, lets you put more functions on fewer keys. This isn't appropriate for a Cyberdeck because there's a chance we're going to be holding the Cyberdeck with one arm. So all common all common functions need to be done with one hand. And I think this might mean we might actually need more space key, or we might need more shift keys and function keys. We have to mirror them more. It's going to be interesting. Yeah. Radovan Obal. Let's make that the last one. Let's work real quick. Not a blue LED ever. I have a DOS keyboard for it as blue LEDs for caps lock, etc., and those pump out so much directional light. I can't believe they're not classified as lasers. I think we'll put an OLED, or at least one OLED in here to display layers and stuff, because that lets us dim it. I think that'll be that's cool. I like the idea of having like a bunch of displays on the Cyberdeck. It's cyber, It's for cyber fun. All right. Oh, we got some great questions. You folks have to stop asking such good questions. I'm not going to be able to get a drop of work in edgewise. Barry Carter says, I have a BT100, want a decent chording input suggestions. This is off topic, but if you want a chording input, there's only one correct answer, and that's the twiddler. You got to get yourself a twiddler. BT100, you're going to have problems because you can't use, as far as I know, you can't use the Twiddler 3 because it's Bluetooth low energy, and they didn't introduce, I might be wrong here. Remember the BT, you might be able to get away with this. You definitely want a twiddler. Twiddler 3 is pretty rad. Have they made a new one? Let's check real quick. Let's go to techgear.com, which is still around. How the hell is Techgear still around? I was talking to the gentleman who runs it a while ago. Oh, there we go. Twiddler 3 is still the state of the art. I know Tony's been working on the firmware a lot. The Twiddler is a one-handed corded keyboard, and this doesn't look like it, but it's very light. I have one here. I have one here. It's up there, so I don't want to rummage around and grab it. But yeah, you definitely want that. It's got a little clit mouse on the back. It's very small. It's easy to hold in one hand. Battery life is quite long for a Bluetooth device, and you don't have to. Oh, they have colors now. Check that out. You don't need to use it as Bluetooth either. If you plug it in with USB, it now works like USB, and it has like a little thumb mouse on it, and yeah, they're pretty rad. So yeah, yeah, I don't think a lot of layers are what we want. In fact, we might even want more keys because we want this thing to be able to be used one-handed for fun. Chronome says, "Don't forget ergobleds in every key." Unfortunately, that's not what we're gonna do today. Unfortunately, not. I mean, we'll see how much time we have. But the problem with this is that the cutout. Let me switch over to our big view here. The cutout that these have for an LED is kind of the wrong size for fitting an ergobled. It's designed for an 06, like an 080, 0806, 0804, 03, 0603. Basically, it's designed for a monocolor LED, and it's unlikely we might not be able to find an ergobled that fits here. Plus, this is a portable device, so we don't. This is a portable device, and we want to reduce our component count. That said, everyone loves ergobleds. Let's see how far we can go. So let's just jump straight into this. So here's the big question. Let's switch back here. So here's the big question. What CAD program are we going to use? I want to use Altium, but I know that no one else uses Altium. I know everyone wants me to use KiCad, but I've never used KiCad for a substantial amount of time. I've only logged maybe 100 hours in it. So I'm not very quick with it. So I'm gravitating towards Eagle, but I don't know. What do you think? Should we leave this up to chat, to myself, or to chance? Looks like the people are saying KiCad, but it might not be a very fun stream to watch because I'm not very good with KiCad. Paul Policastro says Rhino. Torny Beers. I know I'm. Oh, Fusion. Oh no. Let's take a look at that. I haven't checked this out in a long time. So Fusion, at one point, it had an entire circuit board. Let's see. It had an entire circuit board design. Like it had Eagle in it at one point. I don't know if they still do. Where? I don't even remember how to invoke that. Is it in Tools? Nest? Add-ins? Let's see. Scripts and add-ins. Is that? Let's. Get the spur gear generator. That's not what we want though. A spurving bearing. That's right. Fusion App Store. Did they strip it out? Because that would have been a smart thing to do. Let's see if we got CAM. Is that CAM or is it CAD? Data management, general utilities, visualization, woodworking, general utilities, map boards. Let's just search for circuit. No. PCB. No. So maybe it's still integrated in there. Anyone remember how you? Let's see. Mr. McStarcoin says it's the new file dropdown. Here we go. New electronics design. So does this still have Eagle in it, like the entire thing? Let's see. New schematic. New schematic. Let's see. So this is a different. Is this what Eagle looks like now? I haven't updated Eagle in a long time. Because this looks awfully different from Eagle. Let's. Yeah. I guess so. Yeah, it's Eagle. It's got Eagle right in Fusion 360. All right. Here's the big question though. Can I get my libraries in here? Will this let me get my libraries in here? I feel like this is kind of the worst of both worlds because the people want KiCad and it's not KiCad. Yeah, people want KiCad but it's not KiCad, and like, I'm good with eagle, but this is not really eagle. So yeah, is there any way? Let's see, document, validate, automate, library. Maybe it's under library. Libraries. Open library manager. Oh, we have a library manager now. Ah, that's neat. Check that out. So, InDesign, none. Available. Oh, that's neat. That's awfully neat. Let's see. Install bundled libraries. Add from team. Browse. Can we add multiples here? Let's check this out. Wait, what's that mean? Electron. Is this running Electron? Is this a web app? Is this a wrapped web app? What the flux? Thanks a lot for the super chat. Use KiCad, nerd. I just want to explore this for a sec. I haven't. I remember when they added this feature in, and the extent of me using it was me going like, huh, they put Eagle in Fusion. That's weird. So let's see if I can load my libraries here. Let's go to Dropbox, library, Eagle, external libraries, and let's see if we can select all of them. See all these Voidstar and Zack's things? I've made a lot of custom parts in my day. Did it work? Did it work? Did something happen here? What's going on here? Is there Zack's Hack SparkFun boards? We got Voidstar. Yeah, check that out. Yeah. Isn't that neat? Let's add, and let's just see if this worked. Teensy. No, I guess not. Yeah, hang on a second. Yeah, where's our libraries? What the heck? Do I have to update? Update? Why isn't it giving me all my fancy libraries? Hide unpopular parts. Oh, that's just sad. Why do we gotta make it? Why do we gotta make this a popularity contest? So yeah, libraries are missing. Okay. Eris says we're seriously using Fusion now, aren't we? Okay, here's what we're. Let's see. Okay, here's what we're gonna do. We're gonna do virtual dice. We're gonna roll die here. There we go. Did you know that Google can roll virtual dice? Okay, here we go. We're gonna roll a 6-sided die. We're gonna roll let's see here. We're gonna roll a 6-sided die. On a 1, we do KiCad. On a 2, we do Altium. On a 3, Eagle. 4 is Fusion. 5, I pick. 6, you pick. Ready? Here we go. D6. That's it. You pick. All right. So here's what we're gonna do. Yeah, so you're gonna pick. I forget the command for this, but we're gonna quickly put together a little poll. Where's the poll? I don't know how to do this. I don't know how to do my let's see. Poll new, and the title is which EDA. And then we're going to, first one is KiCad, second is Eagle, third is Altium, and fourth, Fusion, and then the last one is pencil and paper. I think this works. I think this is going to work. Pencil and paper, for all the people saying fritzing, pencil and paper is, pencil and paper is going to, could be fritzing. Now everyone's trying to start polls. Now everyone's trying to start polls. No, only mods can do polls. All right, let's open this up and watch the votes roll in. You don't get to see that yet. All right, we're gonna give this. Let's give this 2 minutes. You have until 12:58 Eastern Standard Mountain Time. Yeah. Let's. I'm gonna repost the link so people can see it. Yes, this is the sort of interactive content style video experience that people came here for. But after this, there's no more dilly dallying. We're gonna be no more dilly dallying. We are going to jump right into designing stuff. Why is everyone spamming the poll? Like, you can't start polls. Just click on the straw poll link and yeah, click on the straw poll link and go in there. Yeah, it's not that difficult. So Let's see. What should we do in the meantime? Let's look at more dog. Let's look at more dogs. Let's see what else I could find for dogs. Oh, I had the let's see. I accidentally got some. Put some dog. I downloaded some dog videos, by accident while I was. Oh, this is when we were etching that Pop-Tart. Remember that? Let's see. One of these is when we first brought Peter back, and he was such a scaredy pup. Here we go. He was such a scaredy pup that he didn't even. Oh, there's a dog under the table. Oh, look at that dog of darkness. It's so hard to get these guys on video. They're like pitch black. They're pitch black darkness doggos. This is when we first brought Peter home. He was so nervous. Oh, what a poor pup. Why is it stuttering so much? It's really weird. Oh, he's such a cute pup. He was so reluctant to come in. Oh, look at Peter the pup. It was raining. Look at this. He didn't even want to come in. He sniffed around a little bit, and he just curled up and hung out by the door. Oh, look at that pup. And then we offered him some dog food, and it was this like all natural hippie dog food. And even though he hadn't eaten in like a day, he didn't want to eat it because it's hippie dog food. It was pretty gross. Oh. Okay, it's 12:58. Let's look at the damage. Look at that pup. Aw, look at that pup. He's opened up a lot since then and become a lot more friendly. They're very nice pups. All right. Let's see. The results are in. Looks like, oh god, we're doing KiCad. All right, we got to update. All right, looks like we're doing KiCad. All right, we got to update KiCad because I think my version is extremely old. KiCad. Let's see. Oh, that opened very quickly. So we're running 5.15. Let's see what we got. Let's see. Current version is 5.1. I think we should probably. Well, then, like I was gonna say, we could probably get away with it, but it looks like that this update's like twice a year, so we might want to update. Democracy has failed, says Randovan Obal. I think so. Clearly. All right, where do we get this? 5.1 is made from the 5.1 branch, cherry-picked download. Okay, so while we download this, we'll get the libraries we need. Hopefully, the libraries exist. I haven't used this since before, like for years. So this is gonna be a complete disaster. So much for getting anything done today. Where is it? Where is the download? Oh, there we go. No, you get nothing. No, not $5. Where'd you get $5 from? There. Wait, do I have? Where's the download link? There we go. Where's the download link? There we go. All right, so it's a couple gigabytes. All right, so so what we need is, let's see if we can get this here. Kale, Chalk, KiCad, footprint. Let's see what we can get. Keyswitches.pretty. KiCad footprint library for Kale, Chalk, and MX style mechanical switches and the associated sockets. All right, so this looks like what we want here. Open source KiCad library of mechanical keyboard. Oh, it even gives us pictures. This is a great GitHub project. This person has their act together. So let's see, KLMX. Let's look for the Chalk. Where's the Chalk? I don't know why they call it that. It's silly. Here we go. Oh, there we are. Yep, that's definitely the right. Yep, it's definitely our boy. Just a plain old one-sided mount for Kale switches. Oh, this is neat. Lets you mount the switch on either side of the PCB, similar to the switch mounts in the original Ergodox PCBs. Can I put the switches on the other side of this keyboard? That's pretty interesting. Enables the switch to be mounted on either side and rotated 90 degrees by the person assembling the board. That's weird. That's kind of neat. That's pretty interesting. All right, very nice. Let's download this. I'm not gonna clone it because I don't plan to update this. So let's open that and get it unzipping. All right, let's get that unzipping. Very nice. Next thing we're gonna need is a processor or an I/O expander. I'm thinking we'll use an I/O expander. All right, we probably don't need to keep this open. Rainbow Orange says, "What browser are you using?" We're doing Edge because it's much faster than Chrome, and I can use a group policy to keep Microsoft from sniffing our info. So let's. What else do we want here? I think we want to go the I/O expander route. Let's see. So let's go to digikey.com. Another thing is, the fewer components we need, the higher chance that we can actually do this without getting, our butts screwed by the component shortage. So let's see. I/O expander. I/O silver. Away. Let's see. Got an I/O expander. We're gonna want at least 60 keys. We should probably plan on at least 80. So let's see what they got here. Why is this giving me so much guff? So let's see. We have 40, 48, and 60. This is. Yeah, let's take a look here. We got let's look for 40, 48, and 60. We want them in stock. We want them normally stocking. We want this to be an active part. Looks like we got 9 choices. This is a get rid of analysis paralysis. You got to set up. You got to set constraints. All right, so this one is out of the question because we want people to be able to actually solder this thing. So we're going to try to avoid leadless components as best we can. Pardon me. Right, so this one is, let's see, we have I/O expander I2C 40 points. That could be, I think this is what we want. Yeah, the PCA series. Alex, thank you so much for the ruble. Firefox has tree-style tabs add-on. I generally don't have so many tabs open. This is an exception because we're doing the Every Filament episode, but I try to keep the tabs at 6 or fewer. All right. Well, we don't need. Speaking of, we don't need these anymore. We can close these down. Let's get that out of here. Looks like. Let's see. Looks like Altium, or looks like Altium. Looks like KeyCAD is done. So let's get that showing. Thanks a lot for the super chat. Really appreciate it. Yes, open source software mess our stuff up. What do we got here? KeyCAD is already installed. Oh no. Yes, let's overwrite our existing files. I don't think I've ever done this before. Environment variables. I don't think that matters. Parent files. KeyCAD 6 gigabytes. Wow. I think we're running out of space on the main drive. Gotta clear some stuff off. Obviously, no, we're not doing that now. I think this is our boy right here. Let's take a quick look at the data sheet. This could be it. All right. Oh man, I got my friggin' thing right in the middle. I can't see the bottom of the chat. Red Baron says, wasn't looking at the stream and thought my Linux PC was making all these Windows noises. I know. I should probably pick a different sound pack so that I don't trigger people. Alright, so let's take a look at this. Take a look at this data sheet. The PCA 9505 or 6 provide 40-bit parallel I/O ports for I2 CBus applications organized in 5 banks of 8. By the way, another thing that this gives us is it gives us N-key rollover without having to worry about how fast we're reading. Basically, we don't have to worry about how fast we read the GPIO to get proper rollover and debouncing because this should probably do it automatically. We can read all 40 of them simultaneously. All right. Let's see. I'm going to turn off my system sounds just in case. Let's turn off the system sounds. All right. Output ports of totem pole logic state changes at acknowledge. PCA 9505 is identical, except it includes 100K internal pull-ups on all the IOs. So 9505 is definitely the one we want. That's the one we're looking at here. It's definitely what we want. Device can be configured to have each input port be masked to prevent it from generating inputs. Oh, we get inputs. Very nice. Or we get interrupts, I mean. An open drain interrupt allows monitoring of the input pins and is inserted each time a change occurs. Very nice. We can tri-state everything. We got a power on reset. All right, so this is just a basic I/O expander, except has a lot of pins on it. And I think that's exactly what we want. Alrighty, let's see if we can. Next thing, address. All right, so we have 3 address pins, which gives us 8 total addresses. Mikhail Groen, thanks a lot for the Kroner. You should switch to Linux instead. I don't like Linux as a daily driver. For one, you can't play games on it, but it just has more compatibility issues than Windows. Yeah, I think Windows has become a lot more. I'm impressed with how productive Windows has been. I haven't had a Windows I don't think I've had like maybe 2 Windows moments since I started using since I built my last computer a few years ago. Yeah. Look, don't get me wrong. I use like every embedded device I make uses Linux. Every server I deploy uses Linux. Mac OS is, for many reasons that I've ranted about a lot on streams, Mac OS is dead to me. But I think Windows is still the choice for daily driving, and Linux is the choice for everything else. Yeah, hey, everyone's like, oh, you can play this game on Linux. All right, now just account for the other 99.999%, and also remember all the video editing software, Premiere Pro, Photoshop. Like you can sort of run them, but like they're not optimized for it. Like even with Premiere Pro running on this machine with 2 graphics cards, a 16-core processor, and all that, it still takes a good 20. It still takes a good 20 minutes to render, like 40 to 40 minutes to render each episode, and so even the ones that are only 20 minutes long and 2K resolution. So I can't imagine how that would run on an emulator. Yeah. But anyways, let's see. Ian Ross says, "Okay, hot take. Apple is crap." I wouldn't go that far. I would definitely say that Mac OS is not for me anymore. In particular, the requirement that all kernel drivers are signed is a game breaker for anyone who works with hardware. It just can't be done. There are just too many peripherals and things that you just are never going to get their code signed. Like, come on. All right, so I think this is probably our bet. Yeah, let's see if we can find a footprint for this. PCA 9505 KiCad. I've used the PC. The PCA series is fairly common. If you've used an I2CIO expander before, then you've probably used this. You've probably used something compatible with this. Well, of course, we'll find out later. But on stream is not the time to conduct research. We want to get started. So it looks like we're gonna have to make our own footprint here. So yeah, looks like we're gonna have to make our own footprint. Yeah, I don't know how to do that. To edit or create 3D models, you need FreeCAD. We're not going to do that yet, although it is something we will have to do. So let's open up KiCad. I've never made footprints or symbols in KiCad before, but we're definitely going to want to do that. All right, so how do we do that? Create new project, open project. So how does this work? Manage libraries? How do we do this? See, this is what I was worried about, because I can't really conduct research during streams or I'll lose all the viewers. So we have to just jump right into this. So first, let's see. This is how you add an empty row to the table. Oh, that's helpful. Add existing library. So first, we want to add in the libraries that we just downloaded. Here we go. The pretty key switches. Where are they? Where are they? They're in the wrong format. Maybe there's like a compilation step or something that I missed. Don't worry, we're not going to spend a lot of time on this. We're only going to spend a few seconds. Yeah, if we end up struggling with let's see, not cherry, kale. There we go. If we struggle with this too much, I'll just go back to using Eagle. 'Cause yeah, nobody wants to watch me. Nobody wants to watch me struggle to use a piece of software, unless you do want to watch me struggle with a piece of software. But what can you do about it? Open source KiCad, yada yada yada. All right. How does this? All right. So there are no instructions here. Maybe they changed. Maybe what's the date on here? Last updated in February. 2 years. It says, well, these are from 2 to 4 years ago. So maybe they changed the format. Oh, geez. Maybe they changed the library format. So what format are these in? Let's see. This is called key switch. Pretty. There we go. All right. What do we got? So these are in the KiCad mod format, and what does KiCad? Keep forgetting how to pronounce it. So KiCad wants a .lib file. So let's get on the almighty Oracle and say convert KiCad mod to lib. Let's own the libs. How to convert my local library? Oh, it's a Yahoo group. I'm just gonna nope out of here now. Is there a way to convert mod files to .pretty? What does that mean? If you have the module opener at mod to KiCad mod, how do we do this? Import KiCad mod. All right, how to import into KiCad? Problems importing mod files into KiCad. No, we want how to import using. Oh, I hate watching instructional videos. No, look at that. Come on. Friggin' 20 seconds in. We hit edit, preferences, manage library. Oh, so this is where we were before. Huh? Wait, what's happening here? Add existing library. Folder. Alright, let's give that a shot. There we go. No, it's not letting me do that. Okay, so this tutorial is outdated. How to add, download symbol footprint or full library into KiCad. Files with this represent the current footprint file format. One such file contains a single footprint. How to add a .pretty directory. Is that, oh, that's what we got here. Oh, is it not it wasn't recognizing it because it's GitHub and it added master to the end of it. So let's see if this works. Can't be completed because it's open in another program. Let's close that and see if that helps. There we go. All right, let's try this again. Right, so we're going to go to downloads, key switches.pretty, and it still isn't working. So they must have got rid of this. Okay, I'm gonna time boxing this in 15 minutes. If we aren't into editing this schematic in 15 minutes, then we're switching back to Eagle. So, yep. Let's see. KiCad footprint libraries are how to add a .mod, how to add a .lib. Symbol library is stored in two files. .lib contains symbol information while the .dcm contains docs. How do I convert these, though? Files ending with this library is done within the footprint editor. So does this not? Wait, hang on. So let's slow this down for a second here. There's one. So these are just footprints. They're not schematic symbols. So I'm going to have to bind these to. So does this mean that I have to bind these to schematic symbols myself? Yeah, I guess, right? Yeah, I'll have to. I guess we have to make our own schematic symbol and bind them. I don't know. I've never used this feature in KiCad before, so I don't. I don't know what we're doing. Okay, so let's go to then manage symbol footprint libraries. Go to manage footprint libraries. All right. So let's open. Okay, so this is different. Okay, cool. So this gave us a different diagram, or a different dialogue. So let's go to Dropbox. No, we're going to go to C users, yours truly, downloads. And what was this called? This is called keycaps.pretty. All right, key switches pretty. Key switches pretty. There we go. All right, so I think that should do the job. I think. Now, how do we bind these to? How do we bind these to the schematics? How do we bind this to schematic symbols? Let's see. Let's see. Some people are saying my voice is too quiet for the other sounds on the stream. That's weird. Yeah, it does seem to have quieted down. That's really weird. Let's put this back to. Maybe I might have brushed my hand against the volume. Well, very sorry for that. Sorry for everyone who had to adjust their volume right now. I wish I could go back and, yeah, now I'm going to have to go back and manually change the volume level for the first half of the video, because I have so much time on my hands. All right, let's do this. So where are we right now? Page layout editor. What are we in right now? Do we need to create a new? Let's create a new project. All right, and we're gonna put this in projects, active projects. We're gonna want a new folder, and we'll call this Cyberdeck V2. Haven't named the project yet. If you have any good names for the Cyberdeck project, then please feel free to put them up. And this is going to be the Keeb. I'll put this. Actually, this will probably. Actually, we probably don't need that. It'll probably create its own. Let's do the Cyberdeck Keeb. All right. How do we create a new project? All right. All right. So we're gonna go to this PC. We're going to go to yeah. Dropbox, projects, active projects, Cyberdeck V2. And we're going to call this one Cyberdeck Mech Keeb. All right, so we've created it. So now we start in the schematic editor, I'm assuming. All right. So we start in the schematic editor, I'm guessing. Oh, man. All right. Man, I'm not, oof. Really slow at this. Okay, how do we add, oh man, I use this, literally last time I launched this for a purpose other than opening someone else's design was like 2016 or something. All right, so so we want to place a symbol, I'm guessing. Have some Mio while we look at this. Looks like sewage water. I mixed the strawberry pineapple that Trucku sent me with I think a Cyberry Storm. All right, so those were called switch. What were they called? Key switch pretty, I think. That's what they were called. Key switches dot pretty. So looks like they didn't include. Looks like they're not bound to any sort of thing. All right, so let's. I mean, what do we want? Like this is like a single pole, single throw switch. Yeah, I guess this is it. All right. So how do we bind this to? So let's save this first. How do we bind this to a board? It froze when I clicked the board editor. Oh, here we go. Looks like we got a board. All right. So how do we do this? Let's see. Chronome says, please use software you prefer and are comfortable with. Project will progress faster. Well, we give the people what they want here. What the people want is KiCad. And the other thing is, frankly, stream performance is kind of tanked. So, like, I don't think it makes a difference. All right, let's see. How do we do this? Place footprint, I'm guessing. Let's put it here. It's weird that you place it first. It's weird that you place it first. Look, we'll speed up pretty quickly, right? Because we're placing down like 80 copies of the same item. So let's see what we got. Set Top Vox says, can you explain what an SPST switch means? SPST stands for, all right, so all switches are specified by, basically you have two things that specify their behavior, poles and throws. And the pole means, the poles are, all right, so basically like, a single pole, single throw switch means that the switch has two states. Either you have two contacts, they're either disconnected or they're connected, right? That's the pole. If it was flipping back and forth between connecting like basically you have an A and it's either connected to B or C. That's a double pole, or that's a double pole switch. And then you have a throw, which is how many switches are in it in parallel. So, for instance, like a dual pole dual throw switch is two separate switches in the same device. And depending on where you flip the switch, it's either connecting A and B or it's connecting A and C. So SPST switch is the simplest form. It's either a broken circuit or it's a made circuit and only has 2 pins. So that's what we got. So here we've got, so we should see our footprint here for key switches. There we go. And now we want the Kale, not the socket one. There we go. Yeah, we don't want any of the fancy stuff. I don't see any purpose in adding extra PCB traces to turn my to turn the switch sideways. So there we go. Let's throw that here. All right, how do we zoom in? There we go. All right, let's get rid of this. And I think there should be some in the properties I'm gathering is where we bind it up. All right, let's see. Update footprint, change footprint, edit footprint, board side. Oh, you have a little model. Looks like this one doesn't have one. All right. Let's see. I forget how we... how do we attach these? Is there a tool for it? Dingle Donger says, other way around. Polls the number of circuits it affects and throws to the switch position. Is that true? I need to double check that. All right. Some folks are saying that we in EE schema is where we update the. Why does that zoom in so aggressively? Jeez. This is where we bind them. So let's see how do we do this? Let's see, symbol library, edit symbol fields, edit symbol library references. Is that it? No. Assign footprints. That makes sense. Exporting a netlist requires a completely annotated schematic. All right. Yeah, this is not going to be a fun stream to watch. I'm bailing. We're going back to Eagle. This is not going to be an enjoyable stream to watch. The software has just changed too much since the last time I used it. Watching me struggle with software, having a hard enough time getting people to watch me even do the thing. So yeah, let's open up Eagle and be more productive. So right, so we want Kale Chalk Eagle. Chalk MIDI schematic, clue board, Eagle device library used for. Is there really a low? Is clue board really use Kale Chalks? Let's see, components, hardware. Yeah, what do we got here? Chalk. Yeah, there we go. Huh. Kale Chalk switches. Huh, neat. So this was actually used in production. That's good. That's good. It's good. Yeah. Unfortunately, I don't. Yeah. Normally, I would be more willing to. Normally, I'd be more willing to try something new and to learn a little, especially because that would kind of show the learning process on stream. But I have so little time. Like, I actually do need to make meaningful progress here. I do need to make meaningful progress in this project. We're gonna have serious problems down the line. I barely have enough time to do all the stuff that I have to do. So I am actually counting. This isn't just a demonstration. I really do need to make meaningful progress. What's going on? Why is a door opening? Oh, it's a dog. There's a puppy. There's a puppy trying to force his way into the workshop. Let's see. How's it going, pup? Yeah, there's a puppy trying to intrude on the stream. He wants to be internet famous. That was Peter. That was Peter the puppy. Peter, everything his brother has, eater. That guy, what he wants most in life is whatever his brother has. If Edmund has a rawhide, Peter wants the rawhide. All right, so here's what we got. These looks like we got our libraries here. Eagle libraries have the footprint schematic symbols and the binding in one. They do all three of them. Oh, you hear him howling. He really wants to come in. Okay, so we want to get these things in Eagle. Let's get let's sort these by type, because all we want are the library files. And we're gonna open up. We have to open up a new folder here. All right, so we're gonna go library, Eagle, external libraries, and we'll throw these in. Hopefully there aren't any name collisions, because that's gonna get real awkward in a hurry. Copy to external libraries. Anything? Anything? Huh, good, very nice. Okay, ow. Oh man, yeah, my shoulders and back are killing me. I've been sitting in front of a computer probably for 14 hours a day. Ow. Right. So, do you want a project? I never end up doing. No, I never use projects. I'm just gonna make a. I'm gonna start with this. The good old schematic. We're gonna update. So, we have a little bit of a problem here, and that is I forgot that Eagle doesn't scale with the DPI of the monitor. So, yeah. Hang on one sec. In order for you folks to actually see what's going on here, I have to change the resolution of this display. So, first we're going to put the display density back, and then we're going to... it's going to take a few seconds. I have a tremendous number of things open. Okay, so we want to reduce the resolution here. How small do we have to make this for you to see it? 16. We got 1920 by 1080. Probably want to make this. We can try 1920 by 1080. Let's see what happens. Let's keep these changes. Come on. Don't freeze. Let's just hope has OBS crashed? I don't think OBS has crashed. Nope, looks like OBS actually took that pretty well. I'm a little suspicious, to be honest. Looks like it did kill the schematic editor video or editing window. So we have to open that. Yeah, Eagle does not like having its resolution changed. So let's see. Let's see. Let's add a component. Let's see how big this is. If it's still too small, I'll just up the resolution again. Yeah, that's invisible. Alright, bear with me one sec. We're just going to go back here and switch this to, what do we want? 1440 by 900. That's also the right aspect ratio. There we go. That'll work. That'll work. Alright. So let's pick up our new switches. Looks like they're not in there as Kale. We have Chalk. All right. So we're going to close Eagle, and we're just going to reopen it. This is where our libraries are being stored, right? Yeah. So let's see. We're going to start a new schematic. Very nice. We're going to add... Let's just confirm that the Voidstar parts, yep, the Voidstar parts are in there. So, let's see, Kale? No? Alright, maybe it's called like key switch or something. Oh, man. Ow. Right, what do we got here? Cherry MX. Cherry MX key switch PCB footprints. Is this it? Cherry MX... Key switch? No. That must be from a different project. Right, let's tab back to GitHub page, and let's just take a look at we've got components, headers, controller, keyboard. All right, so this is in the keyboard library. Let's hunt that down. Let's see. Why isn't it showing up here? What's going on? This is weird. I have a lot of libraries. I've been using this for a very long time. FTDI, ICE-HIJK. Where is it? It goes right from Jumper to Landtronics. What's going on here? Why did it not add our libraries? Keyboard? What's going on here? Maybe they're for a newer... Is it possible they're for a newer version of Eagle? than the one I'm using. No, these are years old libraries. What's going on here? I'm a little confused now. I've never had an issue like this happen before. Oh boy. Yeah, I'm starting to get a sense of well, the streams have been good for something. When the dog like dogs get a little lonely, a little separation anxiety, so I sometimes put my streams on at night. They like hearing someone talk, so at least it's good for calming dogs down. Where are they? Where are the where are they? I'm really confused here. I'm really confused. Where none of the libraries I just added are showing up. All right. Don't worry. All right, we're time boxing this. I'm going to solve this in the next 5 minutes, or we are going to we're going to scrap this project and switch to something. We're going to scrap this project and move on to I don't really have this many. I don't have this many backup plans. If this doesn't work, I will. Yeah, we'll do the hardware hardware alternate reality puzzle that I've been saving. I have an alternate reality, like sort of an alternate reality game, except it's actually like a reverse engineering puzzle. And we'll switch to that. Colin Mill says, "Never give up, Fox. Trust your instincts." Unfortunately, that doesn't work when your ability to pay your bills depends on how consistently you can entertain people. So why isn't this showing up? Is it possible that is it possible that I have my libraries hosted in multiple places and we're just looking at the wrong one? All right, so let's check that. Assembly variants. Where are friggin' settings? I have to go back to here we go. We're gonna go to our control panel. We're gonna go to options, directories. See what our eGolder is. I Dropbox library, Eagle external libraries, right? And that's where these were. I Dropbox library, Eagle external libraries. So these are in the right place. That's really weird. Maybe, let's try this one more time. Let's close everything down. Let's open up Task Manager and let's just make sure there are no remnants of Eagle. Nope. Let's try this one more time. All right. Looks like our monitor. Looks like our resolution doesn't completely fill the window, but that's all right. You know what? That's all right actually. Let's put that back. Yeah, today's episode is sponsored by Next PCB. As soon as we somebody says libraries update. That's the first thing I tried. But let's do that again. Let's see, Eagle. I'll take a look at chat in one sec. Let's try this again. So let's go to File, New. Let's try this one more time. New schematic. Let's update. Says update finished. Nothing at all. That shouldn't load new that shouldn't be necessary when we first get started. But let's see. Let's add. Let's see if that keyboard is here. No, we're going directly from. Directly HIJKL. So we're going directly from Jumper to Lantronix. It's not so our keyboard library that we just grabbed. Are any of them coming in? Oh, this is really weird. I've never had this happen. I've never had anything like this happen before. Hardware headers, ICs, keyboard, LCD, and none of these. None of these are showing up. Ow. LCD? No. No, none of them are showing up. Maybe it's a naming problem. Maybe they're coming in at the end. No, that's really weird. None of these libraries are showing up. Damn it! I don't know the solution to this off the top of my head. Let's try to open the library and just see what happens. Maybe if the library fails to open, that'll cause a problem. Maybe there's a. I'm really sorry for the stream being so sloppy. I'm doing my best here. That's all I can say. Oh man, I'm profoundly embarrassed. It's opening the library just fine. Jeez Louise. Maybe I can manually use them. Let's see, keyboard. There we go. Let's manually hit use, and that should import enough into the project that, or that should like, yeah, there we go. So it's just not importing the libraries automatically. That's that's very weird. Okay, so let's grab our. Sorry for the delay. We should be in good shape here now. So let's see, key switch diode, and that's not what we want. Key switch plane. Let's see, key switch plane Alps chalk. There we go. Chalk. We want. Oh, it's got. Oh, that's neat. It's got different. This is very handy. This has different footprints for different units of keycaps, which is really nice. I thought we'd have to design those in ourselves, but all right. So this is what we want. Key switch plane chalk single unit. There we go. I can't believe how long that took. I'm profoundly embarrassed. The next thing we want is to try to find. Hopefully, there's a hopefully someone already made a library for a PC 9505, because. Let's see what time it is. It's 1:30. We might want to just lay out the. Yeah, there's not much we can do here, so we're not using a matrix. So let's see. Pardon the barking dog again. I can mess with the audio to filter him out if he's being too obnoxious. So, Eagle. All right, PC 9505 Eagle. Right. Eagle library object. Microphillips dot p. Do we? Is that a standard library? That would be really that'd be really handy if that were the case. PCA 9505. Yeah, there we go. This is a standard part. Very nice. Ho 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 ho. Yeah, look at this. This just the sheer number of I/O pins this has. This would be a nightmare to do by hand. So let's take a look at our. So let's see. How are these? Let's generate a schematic from this. Let's generate a board from our schematic. So let's see. Move. Oh. I'm just going to move this into position, and we'll zoom in a little bit. I just want to check out the pin numbering here. So this has how many pins on each side? This has 28 pins per side. And yeah, so let's take a look here. So our I/O pins are, let's see, our non-I/O pins, it probably makes more sense to start from that. 3, 4, 5, 7, 10. So it looks like the 20s and the 50s approximately are our control lines. So let's see how that influences how we lay it out. 20s and the 50s. So that's 50s there. Yeah, and the 20s are going to be here. So the corners are where the non-key lines are. So yeah, so it looks like we can be pretty freestyle. Like we can be kind of freestyle this. What's our distance between these? Let's see. Dimension. Right. So first, let's not gird. Let's make our grid nice and fine, and let's do our dimensions. Switch this to the measurement layer, because I just want to get an idea of what the pitch is. So we have 0.5 inch. All right, so we have 50 mils between them. So yeah, we can fit a 20 mil. We can fit a 12 mil trace in between them just fine. So it looks like we're gonna want to stagger these, of going like one. Yeah, so yeah, we should be able to stagger these. All right, very nice. Okay. All right. So let's start laying this out. All right. So yeah, I'm thinking. Here we go. Let's go over to our overhead view. Get that out of here. So let's do some sketch. Let's do some sketching. Yes, gaze upon my sandwich. Gaze upon my sandwich. I don't think I have had a full breakfast on a Monday or a Friday. Like, I guess I feel bad for taking the last stream off, because I feel bad for taking the last stream off. But I'm falling so behind on our content production. I needed the extra day to have any hope of. We can make more of these. One sec. I'm just gonna grab some sheets of paper. Yeah, I'm falling so far behind. We just needed more time to try to catch up, but unfortunately it didn't help because I hope to have the next video done by now, but I didn't. Oh boy. Let's put it this way. If you ever get reincarnated as me, don't look forward to this part. This has been YouTube. It's been a lot of work lately. I've been going to bed at 5 or 6 o'clock for getting woken up by the dogs at like 8 or 10 for the last few weeks. So let's design this. Is this going to show up on stream? Yeah, kind of. Okay, so let's design this thing. We have our screen here. This is about 230 millimeters. All right, and we're going to want we're going to do a 60% keyboard. So it's going to be 5 rows of 6 keys minimum. We have 40 I/O lines total, and we don't. That's not a hard. Although we're not beholden to that limit. We can always change that. We can switch the 40 line one to like a 30 line one and use 2 of them, etc. But for now, let's aim on. Let's all right. So yeah. So we've got our two. So we're gonna do an ortholinear layout because I personally I like ortholinear. I think it's easier to touch type on, and so yeah. So basically, we're gonna have our line here. We're gonna have 1, 2, 3, 4, 5 rows. Right. We're gonna have 12 columns total, approximately. So we're gonna 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Approximately, right? You know, like again. All right, so we're going to be dividing this into 2 separate boards, right? So we've got, we're going to have our left board here. This is just like a sketch here. We're going to have our left board, we're going to have our right board, and we have to leave room. This is important. We have to leave room for them to connect. Yeah. We have to leave room for them to connect, and yeah, if we're going to make this thing foldable, this is interesting. If we're going to make them foldable, we have to have. Well, let's think this through here. What kind of foldable are we talking about? Do we want to have like a ribbon cable connecting them so that they can fold in half like a book? Do we want maybe like them to snap together so like you can fold it for, but like you have to like it's 2 separate pieces that have to come together to type on them? That could be. I keep hitting my mic. Not used to that being there. Yeah, we could have 2 pieces that come together. Maybe with like some sort of magnetic or pogo pin. Have I missed stuff? I have missed stuff. I'm very sorry. That's Mr. Twist You. Thank you. Oh my gosh. Thank you so much for the extremely generous super chat. I am really sorry for not checking chat more often. Thank you so much for the Mr. Twist for the extremely generous super chat. I really appreciate it. It makes a tremendous difference. Just wanted to say thanks for all the info you share on these streams. Much love from London, UK. Thank you very much. Much love from Westminster, Colorado. Thank you so much. It's very generous. I do try to share a lot of info. It's hard building stuff and trying to you know, be educational and make banter and make it fun to watch and fun to listen to and all that stuff at the same time and plan it all out in advance and all that. It's tricky, but I really appreciate it. I've been a bit down in the dumps when it comes to the streams lately, and I really appreciate the support and the encouragement. Thank you very much. Makes a tremendous difference. I really appreciate it. Brooke says, did I see a super chat from Professor D? Oh, did I? Oh, I didn't. I'm very sorry. Professor D says, can we make it not only split or foldable, but wireless and separable, so it can double as a wearable for touch typing, like a Velcro on each thigh? That's interesting. For Wi-Fi or for Bluetooth, that's a tough question. I don't know if we can do. I don't know if it makes sense to do wireless because when it's serving double duty as a cyberdeck, that would pretty much just sit there doing nothing. Let me hang on. This is actually kind of interesting though, because like in this, This is interesting. Bear with me one sec. I just want to check something here. I almost stepped on a fork. I'm grabbing one of the spare boards from the Singularitron. Right, I had the partially populated board from the Singularitron. Here we go. Because I want to see how big this Bluetooth module is. Yeah, so it's got this NRF52 module, and this is really small. It's probably, in fact, this thing is probably about the size of the, this thing's probably about the size of the I/O expander. It's pretty interesting. The question, yeah. So there are a couple questions to answer if we want to use this. I think this is research I'll do after the stream is over, because it wouldn't be very much fun to. It wouldn't be very much like we have to make progress because there's a narrative I have to tell here. But if this thing can act as master and slave at the same time, or controller and peripheral, or whatever way two devices interact with each other without me being canceled, that might not be a bad idea. Could be very interesting. Obviously, we wouldn't use that to connect to the Cyberdeck, but this thing still has a standalone keyboard. So we've got this. we got our keys here. It'd be nice to get more of them. This is only using 30 per, and we have extras. So you know what? Let's go all the way here. Let's do this. Let's do this right. So you notice this doesn't have a space bar. I don't think it's necessary. We could do a split space bar. Like we can combine these keys here together. Maybe that's what we that might be what we want to do here. I'm just oh geez, I keep hitting the mic. I'm just thinking of how I use this. Yeah, I'm thinking that we will cut these and we'll make the bottom row, instead of being 6 discrete keys, we'll make them 3. We'll make them, instead of being 12 discrete keys, we'll make them 6 double width keys. So we'll have like a split space bar. You'll be able to assign both of these to the space if you want a large space bar. But this will also give us thumb keys for like control, for shift, for all that good stuff. And here's what I'm thinking. Let's add, because this thing needs to be more wide than deep. Normally what you want is you want to add more stuff beneath for your thumb. But I don't think that's necessary here. Instead, I'm thinking we add an extra row or an extra column to each side. And we can use this as, let's see, we can use this, oh geez. Can use these as like shortcut keys or macro keys. We can even make them like extra wide, perhaps. Use them as like shift and stuff. Well, one of these is going to be a shift, but I think it'll be useful to have extra keys because for a Cyberdeck we want to have stuff on speed dial. Here's a question: do we want to just tack on an extra row, or should we offset them? Like here, let's make this our sketch side. So like we have our regular 60% here, and then we have a little row that's separate. It's off to the side. I don't think that's a terrible idea. It'd be really sick. Oh man, it'd be really sick. This could be this would be taking it way too far. But make it like a stream deck. Make these like buttons with a screen. What do you? Oh, that would take this all the way to the next level. That would make this a horrible portable keyboard. Oh man, I broke the Cyberdeck a while ago. And I need to make sure it doesn't fall apart too much further because there are batteries in there, and I don't want the lithium-ion cells to short out. Here we go, the displays. Yeah, this is the fun part. We get to let our imagination run wild before we tell it to cut the crap, get back to brass tacks. So we've got these. What are they called? SD 1306. Whatever. They're your standard. They're your standard OLEDs. And I saw this I forget who did this, right? But I saw this really neat design where they took these LEDs. You notice that all the wires, like the 4 connectors, is I2C. So it's got ground, power, clock, and data. And it has them all on one side. So what this guy did, it was definitely a dude, was he mounted this thing to his board, right? Supported on one side. On the other side, he added a momentary switch. So you could use the whole thing as a button. You could press down on the screen to make it click. Isn't that wild? What do you think? Should we do that? That'd be pretty rad. Could have like a bank of these. It's really only practical to add two. It's really only practical to do two of these for a It's really only practical to put two of these in the same I2C bus, but nothing stops us from using like an expander, like an I/O expander or something. Wouldn't that be neat? How many of these could we fit? How many of these could we fit here? So if we're leaving a little distance, what do you folks think of this? Do you think this is too over the top, or do you think it's just the right amount of over the top? Because they should be approximately the same. They should be with the like with the keycaps in place. They should be give or take about the same size, about the same height. So yeah, let's do a little math here. So these are 12 millimeters, and I think with the keycaps these are 20. I think 17. So same height that we've got. So we've got 5 rows. These don't need to go all the way down to the bottom, but see, 5 times 15, 70 something. So that means we could fit like 6 of these. This adds a bunch of width. Hang on a second. We gotta pull up a calculator here because we have a few things to figure out. First one is how wide is this going to be? So let's open up my calculator. There we go. Boop, boop, boop. All right. So let's see. So we've got. So this is going to be like, let's call this 18 millimeters, I think, times, and then regular old 60%. It's going to be times 12. And that gives us 216. So we have about 20 millimeters to play around with. And these things are 30 something. Yeah. So if we end up doing this, it's going to make it, assuming the keyboard is all the way to the side, it's going to make this slightly bigger than, yeah, making this wireless is a bad idea. I just the more I think about this, because not only are we going to have to add a wireless module, we're also going to have to add a battery and a charge controller, and all that is just dead space for the purpose of a Cyberdeck. So yeah, but I kind of like this. So we're going to have 200. So like we're going to have 220 millimeters of. So let's see. We're going to have 220 millimeters of keyboard, right? Is that? Am I getting the dimensions right? I mean, who am I? Why am I even bothering to pontificate about this? I literally have a keyboard with the same form factor right here. So yeah, 18, give or take, more like 20 times 12. Let's see, 20 times 12. That's 240. All right, so this is going to be about as wide as the display for the keyboard itself. Then we're going to add these, and that'll make it, make it a little on the wide side. So yeah, it's going to be this big. It would be really cool though. So the entire thing is going to be this wide, and the Raspberry Pi. Now I'm thinking about it. The Raspberry Pi 400. I'm not going to move this thing around anymore. I'm getting a little scared. Is about 300. So this is still smaller than the Raspberry Pi 300. So this, yeah. So even, yeah, it's still going to be smaller than the Raspberry Pi 400, which is 300 something millimeters on a side. 290 something. So I think this is pretty sick. So here's how this is going to look, right? We're going to have our matrix here. Or it's not really a key matrix, but whatever. So we're going to have our bottom row is going to have our double width keys, because I want to make them I want to make them easier for your thumbs to find. So like, you're only going to have 3 places your thumbs need to be, either far, center, or close. I think that'll make this easier. But otherwise, we're going to have our 60% layout, and you know, we can always mess around with this. We can always, you know, fuse keys together to give ourselves like a big escape or a big shift or something. So here we go. So we've got our keys are like this, except we're actually going to have this over to the side, and then we're going to have our little displays, and each one of these keys is going to be a little display. So we could have like 5 of them, something of the sort. Yeah. So the thing I like about this, thing that's pushing me over the edge for this particular configuration, is because we have because we're going to have the keyboard kind of shifted over to one side, we don't have to split it in the middle, right? Instead, we can split it, let's say, so this is basically the size of 2 keys, right? Yeah, give or take the size of 2 keys. So we actually can shift the split over a little bit. So we're going to end up, we could do it here, but I think we'll end up splitting it here. So we're going to have, there we go. So this is going to be 1/2. And this can be like a macro pad, right? Because we basically have a number pad here plus 6 extra keys. So this is going to be useful on its own. We don't have to worry about, so like even if you don't want the entire keyboard, even if you can still just build the right half, and that will be a number pad. And then this is just going to have keys on it because we can put the processor here. Remember, this takes up a lot of space on the top side of the board, but there's nothing going on the bottom side of the board here, except for the micro switch. We're going to have, except for the micro switch here, this is just dead space. So on the bottom side of the board, we can put all our electronics to drive both sides. And Bob's your uncle. Yeah. So we're gonna have some other things we're gonna need here are I think we should extend the top a little bit because that will give us our ability to put a connector on top right here. Put a connector on top right here. Maybe we could do like a 3.5 millimeter jack. We could do a ribbon cable. Ribbon cable is probably a bad idea though. Maybe we'll do like a little jack. And we also need to, and next to that, we'll put we'll put our headers here. I don't know how big they'll actually be, so that we can connect this to the Cyberdeck itself. So the 2 halves can be wired into the Cyberdeck. Yeah, I think this would be pretty. I think it's gonna be pretty cool. And on the underside of the board, I'm just gonna mock up where the headers and the micro switches are gonna go. But on the bottom, we're gonna have our driver, just like on this side. We're going to use this room up here on the left side to put the driver. But yeah, on the right side, we're going to have our driver, we're going to have our microcontroller, and all that. We'll put USB-C, of course. We're going to have our USB-C somewhere over here. And I think we have a lot of room here. This is actually going to be a little tighter. So I think this is going to be pretty sick. We're going to have some screens. We're going to need an I/O expander. Or we're going to need an I2C multiplexer of some kind. But on the whole, I think this is a pretty cool design. I'm pretty stoked about this. What do you think? Are we overdoing it? Am I forgetting about something important? Oh, we have a little Chronome says, "Oh, thanks a lot for the super chat. Really appreciate it." Suggestion is hexagonal keys. Nothing stops us from making hexagonal key caps, but there aren't any key switches that are hexagonal. So unfortunately, we're locked into some sort of grid-like configuration. Otherwise, the keys the key caps would be much larger than the keys themselves, and that would cause them to rock at the edges. Like when you hit the key far away, there's a bit of a cantilever effect. So I don't think that would make it very comfortable to type on. It would look cool, but I am trying to be a little on the practical side with this. This is like a bit of a product design thing. I would like it if people actually use this after I was done making it. If all goes to plan, this could be Voidstar Labs' first product, or rather the channel's first product. Which one of these is Stream Chat? That's not it. Here we go. Oh, we have another one. Matt, thanks a lot for the very generous super chat. I really appreciate it. Hey, Zack, love having your live streams on in the background while working on my own stuff. Feels like having a friend in the office while I mess around and put seat heaters in my truck seats. Keep up the great work. Thank you very much. And I hope everything goes according to plan and your butt is nice and toasty forevermore. Oh, we got some people saying knobs. Oh, do we want encoder here? Do we want to replace? We could replace some of these screens with an encoder. That could be interesting. Or a couple. What do What do you think? What do you think? We could cut 2 of these and replace them with encoders. I'm not sure how practical that would be on a Cyberdeck though. So like what I'm thinking for the Cyberdeck is we're gonna have like the handles, right, to hold it. And I'm thinking of adding like controls on one of the handles. So maybe like a thumb wheel, like a mouse wheel or a thumb wheel, something like that. But that wouldn't help the keyboard part. Linear encoder, I prefer if it's something low profile, because if we have like if we have big knobs sticking out there, I don't think so. Like the long and short of it is, I'm not sure an encoder is the way to go. But if we want some sort of, this is interesting. Let's think for a second here. I'm not sure an encoder is the way to go, because because that would stick out of the Cyberdeck, and then if we like just throw the deck in a bag or hang it on our belt or like put a strap on it, it can get caught on stuff and get snapped off. Trackball, trackball. That's now we're cooking with gas. So we can do a tiny trackpad. We can do a tiny trackpad. We could do a tiny joystick, either a 5-way or a tiny thumbstick. We could do the PSP style slide stick. I'm gravitating towards a trackball. Very interesting. Yeah. Let's get on. This is very interesting. Do a little touch action. Let's slide to the left and get on. Let's see here. There we go. Switch over to a boring code view. Let's get on DigiKey and see what's in stock, because I don't want to build anything that other people can't make. I feel like that's the case for nearly every project I build on this channel. It ends up having some component that's been out of stock forever. So let's get our butts back here, and let's look for trackball. And we can also check on AliExpress or something. Computer mouse, trackball, navigation switches, joysticks. Let's try this. Let's see what we got here. This is a BlackBerry trackball. Yeah, these are all out of stock. They're all obsolete. Let's see, computer mouse or trackball. So these are quite large and quite expensive. Oil resistant, totally sealed mouse. That sounds like something I am inevitably going to need. So these are self-contained modules and very expensive. Micro module PS2. That could be sort of what we want. We do want that BlackBerry trackball though. I feel like that's exactly what we want. Yeah, but these are all out of stock. I can't put a part in here that we're not gonna be able to source. Let's get back to AliExpress and see what they got. Maybe there's a clone. Paul Rector, thanks a lot for the super chat. Really appreciate it. Pi Moroni makes a neat trackball. Let's see what they got. Pi Moroni trackball. Did everyone know that Pi Moroni stands for Pirate Monkey Robot Ninja? So yeah, we've got a little trackball and a module. Is it open hardware? Because if it's open, so we can't use this, right? Like we can't put this in the product, because if Pi Moroni ever discontinues their product, first off, the markup is going to be nuts. We're gonna, if we ever sell this thing, we're gonna have to mark it up twice. But the other thing is, if Pi Moroni ever discontinues this board, then everyone who wants to make one of these things is screwed. So yeah, the trackball module is a tiny cylinder magnet, each corner, yada yada yada. What are you using? Okay, so this is a dumb track. So this is just a dumb trackball, and under it we've got a Hall sensor. It's pretty neat. Yeah, see, this one's out of stock. Doesn't look like we've got. There's a Nuvoton. There's an MCU built into it. Wow. All right. Yeah, I don't think this can help us, because we can't rip it off. I mean, we can't learn from their schematic, I should say. Let's look for here. Trackball. Why AliExpress? Because it takes too long to get stuff from Alibaba or Taobao or eBay, etc. We can't wait a month for any, we have to at least try to roll the dice on something getting shipped. All right, so these are we don't want a trackball module. All right. So we got breakout boards. We don't want the breakout board though. ICSH044. I've never even heard of that one, but let's take a look. ICSH044A. So we got breakout boards, but do we have the bare part? I guess you don't really buy bare parts on AliExpress, but let's see. 5 key navigation. So that that could be pretty interesting. Patrick P says, what about the nub they put in the middle of the keyboard to move the mouse? We could a clip mouse. Can you even buy those, or are they just are they like proprietary from Lenovo? I guess at this point you must be able to buy them. But let's see. ICSH044A. Let's see if we can just buy the part. Well, we can buy them on Amazon. All right. Well, we could buy the breakout board. That doesn't really help us though. The breakout board's too large. Maybe that's the name of the. Yeah, I'm starting to think that model number is for the breakout board, not for the part itself. But what's the name of the part itself? Or oh my gosh, HW204. That doesn't help. Great trackball at the appropriate output of the pulses, proportional speed of rotation. So it's basically a bunch of encoders. Like it outputs like a pair of encoders, which is pretty neat. Huh. Received item, a ball was detached. Well, that's what you get for buying one of them. Oh, we got a 1-star review in Russian. Let's plug this into Translate and see what this lady or gentleman is saying. This thing sucks? No, it's not English. No, don't put it in Hebrew. Fell apart into parts. Yeah, that's pretty much expected. What's this? Detector module color recognition. Oh, there's some cool little sensors here. That's pretty neat. Okay, we're in the computer equipment section. Let's look for joysticks, navigation switches, or joystick. We're going back to DigiKey. We can do one of these little guys. Okay, well let's narrow this down here. Let's narrow this down here because we want something very small. Mounting style. Let's do through hole. That will, I meant surface mount. By filtering by surface mount, it is going to. Filtering by surface mount is going to cut this down to all but the very smallest. Let's see what's available. Let's see what's in stock. So we got some 5-way switches. That's what these guys are. These are 5-way switches. But all these are out of stock. Yeah, this is going to be a challenge. I don't think this is a good idea. I think this is a trap. Whatever we pick, we're going to have a hard time sourcing. We're going to have a hard time reliably sourcing them. Remember, I'm not building this for myself. I'm building this for other people to work. Or I'm building this for other people to build. So if I was building this for myself, anything goes. Like, I wouldn't even need to do this because I already have a tiny. I already have a tiny thumb trackpad left over from the tiny PC build video. So I'd probably use that. But this is for the rest of the world. So we're only allowed to use parts that can be sourced in large quantities. Sanjay, hey, thanks. Look who's in the stream. We really should be doing some printing, shouldn't we? Maybe I'll take a printing break. But Sanjay appeared in our last stream, and we had a really cool chat about materials and stuff. Sanjay is one of the co-founders of E3D. If you're familiar with their products for hot end, like for hot ends, if you have a Prusa, you have E3D hot end on there. There's all kinds of. They're working on some really cool stuff. I got the printer I've been using lately. Actually, allow me to show you. Check this out. There we go. I've mounted a 4K webcam on the tool changer, so now we can watch prints in glorious 4K resolution. Thanks to my friends at Micro Center. Maybe I'll shout them out at some point. Although today's has already been spoken for. But thanks a lot, Sanjay. That's a really generous stream. Sanjay says the stream rocks. Don't doubt yourself. Love your streams. Ever checked out the M5 stack ecosystem? Pimped out ESP32s with touch LCDs, stackable modules, Gerbil OLE drive packaged neatly in MicroPython libraries. Let's take a quick diversion and take a look at that M5 stack. I've never heard of that. I haven't been messing around with. I haven't had time to mess around with anything that doesn't directly work. That doesn't directly help me either perform better on stream or finish a video. So I haven't really. I've kind of fallen out of touch with what's going on in the in the world of development. But oh, this is neat. Is this like the one M100, the was it IBM one M100 or whatever type deals? It's got little modules you can snap on. It's ESP32 based. It's pretty neat. Who did this? Oh, it's its own company. Oh, that's pretty cool. That's a neat little gizmo. Stack them up. I'm not sure I'd actually want to deploy something like this in a real life environment because it looks very stealable. But this looks pretty cool for building projects. Huh, that's a neat little little dingus. Neat little dingus. There's some cool parts. As for this, this is what I really wanted to use, the thumb joystick. But no. All right. So I don't think this is practical. I'm not sure we're gonna have a. I don't think we're gonna be able to. I don't think we're gonna be able to source these. Trackball. Yeah. Let's see. SMD trackball. No. What? Why? SMD. Oh. Yeah. So I've seen a lot of this module, but this thing's too large. Yeah, this thing's too large to put in our project. I think if we wanted to do something like this module, then we would need to like mount it on the underside of the board with a cutout. How much would this add? This would add at least 3 millimeters. Let's think. If we put it on the top of the board. Probably a bit more. Might not be the end of the world because we're going to have like this already sets our height, so this would be a little taller. Yeah, huh. Interesting. Bitmonger, thank you so much for the super chat. Love this project and enjoy the streams. You can try using replacement Nintendo Joy-Con joysticks. Very plentiful. I don't actually. Are those? What do those look like? The problem, I think the problem with that might be if this is on a desk, right? You're going to be using like the palm of your hand to mess with this thing, and it might nudge the keyboard across the table. Yeah. Let's see. Holy crap! Replacement Joy-Cons are a great idea. I have some just lying around. Jose Machiel says, "Why don't you just desolder it and put it in yours?" Well, because I want other people to be able to reproduce this project, and I want other people to be able to reproduce this project, and putting in the instructions, desolder this part and then stick it on your board, I think is a little. I can't really expect people to have Chip Quick or a hot air gun lying around. Yeah. So could do this. You know what? I think we're gonna stick to our. For now, we're gonna stick to our guns, and we're just gonna use the button, the display switches. Let's. Real quick, let's look into a trackpad. Maybe. Oh my gosh, I'm so tired. Maybe that will help. Oh, we could like embed it directly into the board. That would be pretty interesting. Let's see. I2C trackpad. Yeah, I'm looking for one of the little modules. Touchpad module. No, not mouse. Why is this autocorrect so friggin' aggressive? Touchpad module, not mouse, module. I'll put a tiny LCD screen in it. I think the OLEDs are still smarter. Yeah, these sites aren't easy. Let's put it this way. Like, I'm sure it's on here, but these sites are not. You need time to navigate these things, and unfortunately, that's a resource that we don't have. So I'm thinking that for now we'll stick with the buttons, or we'll stick with the OLEDs, the SSD1306s. Yeah. TKM K says, why not slider sticks like the PSP or 3DS? They won't add much height. I don't think we'll be able to source. I don't think it'll be easy to source them. Remember that it's not enough that. Remember, it's also not enough that they're in stock right now, right? If, you have to think about, how long do I want... Because not everyone who wants this thing is going to, hear about it on day one. So we want to make sure that whatever we buy, people are going to be able to get a hold of in 5 years. And I'm a little skeptical that parts like that are not going to be used anymore. Yeah. Logan says, "What's the difference between Alibaba and AliExpress?" I mean, they're completely different websites. One of them is more. Alibaba is more for sort of buying large quantities of stuff. It's more for like learning about like connecting you with suppliers so you can place large orders. AliExpress is more direct to consumer. Pardon. So it's easier to get small quantity. It's easier to get small quantities of stuff on AliExpress, and the sellers are expected to ship faster. It's also it's also like AliExpress it focuses on international sales. Alibaba is also for domestic sales. Yeah. Chronum says, "Wait, wasn't it a touchscreen? So what do you need a trackball for?" Well, I want the keyboard to be its own independent device. So if a trackball or something would be useful, we'll use it. But yeah, I don't think so. Is there a thing as a low-profile encoder? Does that exist? Does that exist? High profile, like low linear encoder. Like they have to have a stick on it, right? Like, yeah. Alright, so there are these guys. mkultra.click. That sounds like a scary website. Let's check it out. The MK Ultra Corporation. What? Oh, is this a keyboard website? Is this like a thing for keyboards? Low profile rotary encoder. That could be interesting. Made by Alps? I didn't even know they made rotary encoders. Is this on is this RGB? No. I wish it was. Alright, that's interesting. Could add like a little low profile encoder. Put a little wheel on it. That could be a little weird. Yeah, a little rotary encoder. Huh. Yeah, that could be pretty interesting. Honestly, though, I think I'd rather just have more of the switches. Like I'd rather. Oh, jeez. I'd rather just have more OLEDs. Yeah, I think that would be fun. Oh, we got a product number to check out here. Andreas Bested Nielsen says SparkFun calls their BlackBerry trackball uses the AN4884. Let's take a look. Let's see what that is. That's not promising. That's when our the AN it's 440B. There we go. There we are. Panasonic Electronic Components. This is a linear, or this is a Hall sensor. So this is the sensor component for the trackball. See what people are buying this with. We can't. They're not showing it. So this is an obsolete component. I think this is a non-starter. We'll just go back to we'll stick to our idea here. Alrighty. Boop. All right, so we got our drawing here. So we're going to let's think here. Let's think here. I'm gonna lay out both boards on this as the same drawing in Eagle. We're gonna put them all. We're gonna put them on the same drawing. We're gonna add in our routing, like the routing ourselves. So we're gonna add in the routing ourselves. We're obviously not gonna finish this thing today, but we can try to make as much progress as possible. Basically, what I'm thinking here is that we're gonna have this thing that snaps apart, right? So we'll order the boards so that they arrive. So the left hand half and the right hand half arrive as one board. And if you want to make the split version, you just break the board in half. Otherwise, the electrical connections are made there, so you don't need to wire anything up if you want to either put it in a Cyberdeck or if you want to use it as a mechanical keyboard. Which I think is going to be pretty fun. Logan says, "How much would this cost?" You mean you got to clarify. Do you mean how much does it cost to make, or how much would I sell it for? Because the two are different. How much would it cost to make? Probably in terms of parts, if you were to buy them at low quantities, depending on Next PCB, depending on the rates that Next PCB gives us, today's sponsor, right there in the corner. Use the link in the description to get 30% off your order. It's hard to estimate this stuff. I'm guessing $100. I think it's a pretty safe. Although, like, these things could cost a bit. Let's call it $120 in parts. If I were to sell it, the maximum somebody would pay for a keyboard. The maximum somebody would pay for a keyboard is probably $200. So we'd have to do a pretty substantial group buy. The price. All right, remember, folks. A little business lesson for you. Price has nothing to do with cost. Just because something costs you a lot to make doesn't allow you to sell it for more money. If you have something cheap, right? Like this cuts both ways. Listen up, everyone who sells stuff online. If you're selling a module online, right? Like, or let's say you're selling something to. I see this all the time for hardware hackers, right? Like someone sells a Nerf blaster, right? Like they make a Nerf blaster and like 3D printed, and they sell it for like $50 because they know it costs them like a third of a spool of plastic and $20 of hardware. So they think like, oh, it cost me $25. I'll sell it for $50. But that's the wrong way to go about it. You don't think, how much did this cost me? How much is my markup? You think, what will people pay for this? Because if people will pay $120 for that blaster, charge $120 for it. And the flip side is there's a flip side to this as well. This is for the business people, the hardware startup people. So if I'm thinking through this product right now, and I think it's going to cost me $120, right? That is if people, I think people are going to spend at most $200 for a keyboard, right? It doesn't matter what you put on the keyboard, doesn't matter how much labor it is. It could have a handmade wooden enclosure, or it could have a piece of plastic crap that I order from a shady back alley injection molding shop in Shenzhen. It doesn't matter. If people are going to spend $200 on a keyboard, it's up to me to figure out how much of that I keep and how much of that I put into the product. And most importantly, doesn't matter how much a product costs you to make. If people are going to spend $200 on it, nothing ever allows you to charge more than $200. So, keep that in mind. Basically what I'm saying here is that if you're making a product to sell, which I'm not here, very important. I'm making a product for people to reproduce, but I'm not intending on selling it. But if you're making a product for people to sell, figure out the price first, then figure out how to build it around the price. Cost and value and price have nothing to do with each other. Your cost, value is a philosophical construct. It doesn't exist in reality. It's an ideal. Value is a philosophical concept that doesn't exist in reality. Cost is a business reality that's determined by how often you start something new and how many things you make each time. And finally, price is what people are willing to pay. Three have nothing to do with each other. Don't mix them up. Don't do it. Don't mix them up. Anyways, I'm planning on making this product. I'm planning on making this project for other people to copy, but I'm not necessarily intending on selling it. If I was going to sell it, I probably wouldn't be taking this approach, with all the screens and the the low-profile stuff. Instead, if I was planning on selling it, I would figure out what do people want. Probably something high design. I would probably make a very designy product. It's the nature of the game. Anyways, let's see if we have an OLED footprint. I think I might actually have one. Let's see. I might have one. Do OLED. This is the 8. I guess I don't. I guess this is what I was thinking of. 96 by 16. Oh, wait. Hang on a second. I was thinking here, maybe we can get away with just putting the OLED itself integrating it directly into the board. But that's not going to work because we actually want the module here. This is a time when we actually want it in module form, so no good. So let's see if we can find an Eagle footprint for this. All right, let's see, Eagle SSD 1306. I think that's what it's called. I think that's what it is called. Display OLED. Ow. Oh my. Veldurk says the future is haptic gloves and the keyboard existing only as software. I definitely I'm not quite that bearish, or I'm not quite that bullish. But if wearable computers ever do take off in a big way, I think a data glove is going to be a key part of it. Yeah. Hugo DC says, who are you targeting with the Cyberdeck? The Cyberdeck itself is for nerds. There's a reason why, I think parts of this project are more valuable than the whole. In particular, I think the keyboard itself, the keyboard part is the most general interest. Display OLED 128 by 64. We don't want that. We want a 128 by 32. So we're close. We're close here. SSD 6. Let's see what we got here. Is this it? 13 OLED. Oh, that's very very helpful. Please, even if you're just even if like you're just putting your project up there, like even if you don't care at all, at least put a README to tell people what it is. Yeah, libraries for Autodesk Eagle, designing a project 30. All right, so there's no convenient one. That's fine. That's totally fine. We're just going to add header 4. So we're just going to add a 4-pin header. Oh, I keep forgetting it's called a pin. Here, let's go. I keep forgetting the names of the parts. All right, so this is going to be the in the pin head. There we go. Pin header 1x4. There we are. So this is what we want here. We'll just draw. Yeah, like it's just a header. It's just a header. We'll draw a box around it to signify what the size is, and we'll just yeah. Oh, Matt Cirillo says add a gesture sensor. That's an interesting idea, actually. That's huh. What do you folks think of that? Like being able to like wave your hand over it to do stuff. Not a complicated one. Like I put this module in the Singularitron that can do just basic like left, right, zigzag, circle, like just basic stuff. Would that be of interest? I'm thinking that if we want for the purpose of the Cyberdeck, we might want to put that on the near the screen so you can do it facing the monitor instead of over the keyboard. Like, although kind of for the most part that works. I'll keep that. We'll put that in the back burner. We'll think about that. That could be pretty interesting. Remember that for the purpose of like. They're limited. There's a sharply diminishing returns on number of features because you can only put so many things in a headline, right? So like if we put too many things in here, we can't say this is a split keyboard with OLED screens and a gesture sensor and a trackball that's also a Cyberdeck. We would have to just call it like the world's most advanced keyboard, and then we'd have to like. Probably buff up other stuff. But, yeah. It could be neat. I'll put it in the back burner because it's only one chip. It's a lot less complicated than it sounds. So we've got this. We'll duplicate that. So the next thing we want is we want how thick is this here? Let's see. Just ballpark here, about 2 millimeters. So let's see if we can find a micro switch. It's in the neighborhood of 2 millimeters tall. So let's add. Let's see. Single pulse, single throw. What do we got here? That could be interesting. EVQQ2. How does that's the Adafruit's part. I just want to confirm because like I think it's these little switches that are here on this board, which are pretty small. EV. Oh man, I'm so tired. I can't even remember I can't remember 5 letters and numbers. RK66 is angling at getting banned. Let's see, EVQ2. I'm glad folks keep testing the bots and the mods because keeps everyone on on their toes. Right, Panasonic EVQQ2 series tactical switches. Tactile switches. This is, I think, exactly what we want. Light touch? No, we want heavy touch. Where's the... Let's see. Oh, we get options here. Newtons. Very nice. We get to tell it exactly how beefy we want it. Right, with or without ground terminal, operate height and operating force choices. Very nice. 2 millimeters. Perfect. It's exactly what we want. So let's get back to our schematic, and that is exactly what we want. Oh, jeez. We have to make sure we can buy it. Looks like there are Brazilians of these things in stock at Mouser, so they're going to be everywhere. Mouser's DigiKey keeps larger stocks than Mouser. Yeah, so we're going to have a few of these guys. You know what, let's just get in here and label this thing now. All right. So we're just going to label this now. And label. We're going to do our fancy XREF labels. There is a difference. Oh. There is a difference between these types of labels and the pure text labels, but I don't know what it is, and I just think they look nice. I'm kind of basic like that. What can I say? There we go. Let us split. Oh, why is this not? Oh, come on. Give me a friggin' break here. He says as he get it because I'm splitting the. There's one thing that really pisses me off about Eagle, and that is you can't type move. Like M doesn't move because it sorts the it resolves ambiguous partial commands by alphabetical order, and the module command is ahead of move. So I'm so used to just typing M because when I learned Eagle, the module they didn't have the module functions. Let's see. Jeez. Oh, jeez, Rick. So I am really used to just typing M for move. Still, it's funny. Like you build up muscle memory. There we go. All right, and let's name these. Luckily, the module has names written right on it, so we're going to call this ground, and this one is going to be VCC. Actually, hang on a second. Jeez. Let's get rid of those because, yeah. All right, this is This is serial clock. This is serial data, and this is our ground. This is going to be a bit of a tingle for a sec. We'll straighten it out soon. But now we need to add some symbols. Let's add ground. And let's also add a 3v3. I want to remember that this is this needs 3 volts. Because we're going to have 3 volts and 5 volts flying around on this board. So yeah, let's get this over here. Now let's straighten this out a little bit, make everything look nice and pretty. Yes, making your schematics look nice is more than just aesthetic. Less confusing, the more clear your schematics are, the fewer mistakes you'll end up making. Never underestimate how resourceful people are when they're making mistakes. And yeah, it's going to take me a bit to get used to not constantly zooming in all the time. Unfortunately, the Space Mouse does not do anything in Eagle. That would be pretty cool, though. Meatwad asks, is the Cyberdeck keyb using normal switches or low-profile switches? We're using low-profile switches. We're using low-profile mechanical key switches. All right, and we've got our switch here. Let's see. Let's move this guy in here. And let's just get... right, symbols, info, guide. What do we want to... I don't really draw a lot of these. I think info is what we want. Yeah, basically I'm going to draw a box around this and just make it look like SSD 306, 128 by 32 OLED. I squared C OLED. We're just going to put that right here. Yeah, very nice. give ourselves a little extra room here. Make it look a little more like the real deal. And we want to just add in, let's add in a little box around here just to make it look a little more OLED-y. Very nice. All right, so we want to copy this. So we need let's aim for 5 of these right now. Copy. Let's aim for let's make 5 of these. We can always change that later. Or should we make 6? Should we go all the way? Yeah. Let's make 6 for now. So, yeah. And let's get these out of the way for now. Okay, so now we have key switches. Let's see. How are we going to name these? I guess we'll just name these left to right, back to back. Pretty nice. Folks are asking if Eagle's discontinued. No, it's part of Fusion 360. Although I think you can still get a standalone version, I think. Yeah, I think so. Oh, am I getting what's going on here? Oh, am I getting Windows sounds? All right, all right. Oh, crap. I forgot that I had my my Windows sound turned on from the interview. I'm sorry for all the notification sounds you're getting. That's my mistake. I have I turned on the sound. Oh, jeez. I turned on. Oh, that's why I don't have any hard drive space, because I've been recording the entire stream by accident. Ah, that makes sense. I'm going to delete that afterwards. I had system sound going to the stream for my talk with Sanjay the other day, and I forgot to turn that off, so I'm very sorry for annoying you with notifications. I thought they were coming in through my mic. Yeah, I thought they were coming in through my mic. I'm real sorry about that. That is my mistake. All right. So we're doing an exact 60%, I think. I guess we can always add more later, although renumbering them is going to be hard. I think we'll just, you know what, let's stick to our guns. People want to see us, people want to see this move forward. Why is this called a U? I don't like this. I don't want this to have the U prefix. Let's see, we're going to open our device, and what should this be? It should probably be SW for switch, right? Prefix should be SW. That's right. Let's save this. Let's update all, update schematic modified. Let's see. Are these labeled SW? All right. So good. So let's name this. Name this guy, and we're gonna call it SW 1 2 3 4 5 6. So we're gonna call it switch 7. And let's just see if when we copy it, if it's named correctly. Yes, excellent. Cool. So let's make. Oh. All right. So we've got. So these have pull-up resistors. Cool. So one of these is going to. One of these is going to go to ground, and the other one is going to go to. One of these is going to go to ground. The other one is going to go up to our dingus. I think that the middle one should be ground, and the middle one should be ground, like middle pin, and the side one should go to the other one, because then we won't have to meander traces around the center pegs. So let's do that right now. So this guy, we're gonna bring this over here. Let's see. I'm going to bring this guy over here. How do we want to organize these? Because this schematic is going to get out of control if we... the schematic is going to get totally out of control if we wait, or if we aren't clever about how we do this. I think we'll bring those down. I think we'll bring the grounds down, link those together, and we will... let's see. And these, we can either bring them to the top and label them, or we can just route them directly I'm thinking we bring these just straight up, and I think we might route these straight into this, because otherwise we have to fan out all these signal lines. Ah, what a pain. All right, so let's get this. Let's do this. Actually, hang on a sec. Made a little mistake here. CXOB says, what about diodes? Kronholm says, are you not doing rows and columns? No, we are going to hook these straight into an I/O expander. I know it's not hackery. I know it's an inefficient use of resources, but the key resource here is time. And I'd rather just add a $5 I/O expander to each board than have to solder 60 diodes and then have a chance of the board failing if we solder them in backwards, and also having to multiplex and debug a matrix. So no, we're just going to run all these things into an I/O expander because we're lazy. No, it's because it's not laziness. It's not for laziness. It's for an efficient use of resources. I've got to stop moving this around. We're going to shorten this so that they don't all combine together so these don't combine together when we start copying them. There we go. And then we'll group these. Copy all 4. Copy 2 again. Oh, those were... we didn't line them up. There we go. Copy these 6 to get 12. Yikes. Getting a little close. Let's get these out of here. Might even want to put them on a separate sheet. Yeah, we wouldn't be nearly this fast if we were using KiCad. I know the people wanted it. I wish I was better with it. Yeah. So what happened was, like, I was using Eagle for like pretty much all my career, right? I was using Eagle, and Eagle got bought out, and that really pissed me off. Eagle got bought out, ticked me off. So I started using Altium, because remember, I wasn't planning on doing a YouTube channel. I was going to do work for clients, and Altium's just like a bit higher productivity, you know? So I didn't use Eagle for a while, and just never got into KiCad, because there wasn't really a reason to. All right, there we go. We have our matrix. So anyways, like, KiCad at the time was also kind of crappy. Or back when I was deciding... So, like... KiCad was, I think it was fairly good at the time I switched to Altium. That was only about a year or so ago. But the problem was that nobody else, like, the industry doesn't use KiCad. Prototype developers often commonly use Eagle in a professional setting. They often use, like Altium. What's the other one called? Cadence. Or Easy, I forget the name of the other one. Basically, they're common. Yeah. So I never really had a reason to learn KiCad, because Eagle was still like, nowadays people are switching to KiCad because Eagle is increasingly crappy and KiCad is better and better. So at some point I will have to Easy EDA. That's the other one. Thanks CXOB. At some point I will have to eventually learn KiCad. We'll see if that ends up happening, though. I don't have time to learn anything. It's kind of the nature of the game. All right, one thing we got to do here is we got to junction up all these wires. So let's grab a question, because this is going to get real boring. Let's see. Andrew Brainy says, first layer down on my custom plate and case for hand-wired mechanical keyboard, 7-hour print. That's a pretty economical design if you're doing that in only 7 hours. What? Why is this? Why isn't this working? What happened? Is this off? Why is this off grid? What the heck is going on here? What is going on here? Why? So it's not letting me put this junction down because we somehow ended up off grid. How'd that happen? That's really weird. At least it's only going to take a few seconds to reconstruct this. But how did that happen? That is super weird. Basically, like, Eagle expects everything to stay on the same grid. And we can't use the junction tool to combine things together if that's not the case. Don't worry, this only takes a few seconds to copy all this over. Let's see what we got going on here. The standalone newer version of Eagle has a circuit simulator. I don't like circuit simulators. I just they end up being like just massive time sucks. They just end up taking a lot of time, especially because very few components have like spice, like their spice parameters set up right. So remember, like, you can't simulate a circuit unless every component in that circuit has like a spice model made for it. Which, you know, if honestly, I don't know how people can still use simulators, because like there's so much digital logic, right? You're not going to simulate a microcontroller, you know. Let's see here. Boop, 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 boop. Mish the Mish says, can't you just do one switch and place an array of them? Can you do that? Can you place an array of parts at once? And can we do the wire as well? I guess we could have like modularized this. That's fair. That's fair. We could have modularized this. Don't worry, we're done. Don't worry. This part of the process is done. And let's just junction them together. All right. Toby Schneider says, "You making the board hot swappable?" No. I mean, there's only one brand of like, whatchamacallit? Like, we're using chalk switches, right? Like, there aren't any alternatives to that, right? So unless you want to switch your board between like tactile, linear, and like, unless you want to switch between the three types of those three particular switches, I don't think it's going to matter. Plus, like, that'll increase the footprint, or that'll increase the thickness. Thick. And that's not something we want in a Cyberdeck. I like the idea of making this keyboard thin. There are low-profile keyboards out there. I know, but mine's special. All right, fine, I get it. There are other low-profile keyboards out there, but there aren't as many of them as there are thick keyboards, like full-size Cherry. Could have used the Cherry MX low-profile, but they are harder to get a hold of. They're harder to get a hold of than the Kales. All right, what do we got here? Famatory says circuit sims are only useful for analog design, audio stuff, transmission line. Yeah, that's fair. They are very useful in audio. That is true. That is totally true. Analog circuits in general. Yeah. I think they're I think they're more popular with people who, the real engineers who went to, like, engineering school and did a lot of analog circuits. When I was at Stevens, when I was in engineering school, I used Spice a lot, or at least I was assigned Spice a lot, and I failed a lot. Oh my, I had such, last night, or a few nights ago, I remembered just how rough I actually had it trying to get through engineering school. It was really something. Okay, so we've got, so these are all ground. Let's, yeah, these are all the ground connectors, or ground wires, so let's net these all together. Yeah, so let's we're gonna net these all together. Let's add in our junctions, and then we'll add in our ground symbol. Oh man, was that ever rough? I'm getting flashbacks now. Yeah, I think we were just using like P Spice or yeah, I think it was just P Spice with circuit simulating tool, and I found it easier. Oh my gosh, I found it easier to just go to the engineering lab and rig up the circuit and see what the oscilloscope had to say. Oh man, what a mess. I was a terrible student. So let's see. We got our pull up. That's already been provided. Our pull ups are automatically built into the chip. So really, all we have to do is route these. This could get a little weird. So we could just throw this up here and just. I think that's still the best way of doing it. All right, we need to be careful here. Actually, we got to be careful because there are two sides to this. We got the left side and the right side, and each one is going to have to get its own I/O expander. Yeah, so these can go right here. This is our approximate layout. This is going to be a cool-looking keyboard. We have to save. I haven't saved at all. That could have been a disaster. So let's go to projects, active projects, Cyberdeck V2, Cyberdeck MetKeyb. There we go. Yes. Oof. 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 Let me think here. CXOB says LT Spice is the one we use at university. Yeah, that's Linear Technologies proprietary. So not, I guess they're fork of P Spice, I think. And yeah, it's more usable. Let's put it that way. Let's see. So this is gonna go somewhere over here, and we want to route this here. Let's, instead of thinking this through, right? Never spend time thinking about something that you can just do. So let's move this over here. Oh, let's move this over here. How are we gonna do this? This is gonna go on the bottom, right? Because we're gonna. So let's get this on the bottom. It's going to go on the bottom because we're going to be putting the OLEDs over it because we're cool like that. So let's get this guy over here, and this is going to have the OLEDs over it, switches over here. Kind of hard to see, I know. OLEDs here, switches over here. Why did I not put a command to hide the layout? We could net label this. Let's see. Era says, "What? You can't just connect the rows? You want to use an I/O for every key?" Yeah. I think it'll be easier because then we don't have to use diodes, and then there's no chance. Remember, there are two things here. We don't have to worry about diodes, which is going to save a bunch of time now and when I assemble. And the other thing to remember is that running the stream is very mentally taxing. So odds are extremely high that if I try to design something as complex as a matrix while keeping the stream alive, remember, I can never go more than about 2 seconds without talking because people will think their connection dropped. And I also can't meander in circles if I get too, like, I can't go into the tank. So it's very mentally taxing to actually run the stream. So I'm not confident in my ability to route something as complex, or to design and route something as complex as a matrix while holding a conversation. So, and also keeping on top of doing all like the homework. There's a lot of bookkeeping and stuff I have to constantly keep an eye on. So yeah, anyways, what we're doing here is we're going to, so this is on the bottom. We're going to have to turn this, yeah, we're going to be routing all this on the bottom. That's fine. So we want to we want the routing to be as short as, we want the traces to be routed in the easiest way possible. So we're going to want to be routing these things top to bottom, right to left, using the right side and then using the left side. I think that's the way to go. Yeah, the background, I'm not using background music for a couple of reasons. The first is that there's really, when it comes to stream music, when it comes to putting royalty-free music, when it comes to putting music on stream, right? There's really only one game in town. I think it's Stream Beats or something, and they don't have they don't have a tremendous number of tracks, so it'll start repeating after a while, and yeah, that's not acceptable. It's not acceptable. Obviously I can't just like start running other music because I'm gonna get copyright struck. Yeah, just the sheer because of the way the streams work, just the sheer volume of music. Like even if I'm using like Creative Commons or like royalty-free music, just the sheer number of tracks that are going to appear on all these streams mean that at some point, like it cranks up the odds that at some point in the future, one of the tracks gets sold to somebody who changes its license so it's no longer Creative Commons or something, and then copyright strikes it. So it just it'll drastically increase my attack surface for being copy struck. Yeah, it's the nature of the game. Nanda Scott says, doesn't Monster Cat have a licensing thing you can buy for streaming? And Toby Schneider says, what about Epidemic Sound? You folks overestimate how much money I make on this stuff. Remember that I have to pay for this forever. Because if I ever let my license lapse, all of my streams are going to get struck and claimed. And my channel will go... S2 says, yeah, for sure. Zack, what's the name of the intro song? That is XF, a word for having sex, by Sukov. Yeah, it's funny because like it's definitely the best Creative Commons track I've found so far, and I've done a lot of looking, and I use it as often as I can, and I think it's great, but I can't actually put the name anywhere. Luckily, Creative Commons licenses don't require you to credit the name of the track. They only require you to credit the author. So we're in business. But yeah, that's the nature of the game. JS Diddle says, Zack, do lo-fi. Lo-fi Girl made all the music royalty-free, even streams. Yeah, but what happens if she sells any of the tracks? Like, remember that a license doesn't... It's not like... A license isn't a contract, right? Like, when you use a piece of Creative Commons content or if you use something with a permissive license, that's not a contract. It doesn't lock in the terms, right? Like if I download Creative Commons, like if I make a track, right, and I release it Creative Commons, and first off, just because it's Creative Commons or because it's been royalty free or something doesn't mean you won't get copyright struck. Like, remember, the copyright striking is an automated process that works off other people's channels. It checks that one channel's content is similar to another channel, or that a video's content is similar to a video on another channel. On top of that, it doesn't lock in the terms. So if you use a piece royalty-free or Creative Commons or any of that, nothing prevents them from selling that track or something, and then you can still get copyright struck on it down the line. That's happened to a couple of people. It happens. That screwed over a ton of Twitch creators. At one point, Twitch, like, basically Twitch didn't have a great system for copyright striking, and then when they edited their system, suddenly basically every single Twitch creator said, hey, you have 2 days, literally, to remove all the copyrighted tracks from all your VODs, or we're going to delete all of them. So yeah, that's the nature of the game. Let's build some stuff. So we're going to want to so let's see. Yeah, I did get sidetracked. I'm extremely tired. These dogs have been waking me up really early every day, and I've been going to sleep later and later. I don't think I've gone to sleep before 5:30 for weeks. So let's see. We're going to want to try to route the right side and then the left side. So, yeah. How are these organized? I think this will work. 20. So the 20s are... Yeah, the 20s are kind of like housekeeping pins. 22, yeah, so this starts at, what's our highest pin on this side? 25, 26, 27. Whew, there we go. So this is really going to look like a mess. honestly, let me think here. Honestly, this is gonna look more. This is gonna be more of a mess if we try to label everything. So, let's see. Yeah, look at all these. That's gonna be fun to lay out. All right. So yeah, let's try to lay this out right. Okay, so let's go here. We're gonna. It doesn't matter which side we do. We're just gonna route the B side first. There we go. Up. Pardon the weird zooming in and out. I don't dropping the resolution enough that everyone can see what's going on. Kind of requires me. Okay, cool. So that's our lowest one. And then we're going to switch to our, let's see, then we're going to switch to this guy over here. We're going to route him, and we're going to route that to the second lowest. Yep. Very nice. Cool. Cool. Yeah, and hopefully this makes it easier to, hopefully this makes this thing easier to route. Honestly, there isn't really a lot of, I know some folks are worried about the challenge of routing this, but there aren't that many components on this. The thing that makes a board challenging to route isn't the number of wires. Right? It's not the number of signals that have to be routed. It's how many things they have to be routed around. And if we're even just a tiny bit careful here, if we're just even the tiniest bit careful, I don't think it'll be that difficult to avoid. I don't think it'll be that hard to avoid smacking into other components. Remember how physically large the components are. Remember how physically large these switches are compared to the traces. Like here, let's compare here. So the distance, so the tightest routing we have to do here, right? This is the absolute tightest. Is between this mounting peg and this pin. And this is back of the envelope, counting annular rings keep out. This is 1.7 millimeters. The trace, 1.7 millimeters, let's call it 1.8, and let's switch that to inches. This is 70 mils. So even in the tightest clearance, we can still route 3 or 4 traces. And we can still, I say 3 or 4 traces, but it's actually 6 or 8 traces because we can go top side and bottom side. So this is going to be a really easy board to route. We have a lot of room to mess around here. Chronum says, is there an automated way to batch route? I mean, I could write a script, but it would take longer to write the script than to do the job. It's just part of the fun. Plus, I've been busting my ass on such ridiculously cerebral tasks. I just want to zone out and route some wires once in a while, Yeah. There you go. Let's see. Oken O asks, how many hours do you get for sleep? Oh my. I try as hard as I can to get 7 hours a night, but practically speaking, it's been closer to 5 between having to stay up extra, between having to crunch more work each day and getting woken up early by the doggies. It's probably been closer to 5 or 6 hours, which is not sustainable for me. I have a window next month. I have a window next. If I get everything, if everything lines up, right? If everything goes according to plan, then I get this window September 7th, 8th, and 9th that I can take a few hours off each day, and hopefully, or I can consolidate the work into one day and then take a day or two off, and hopefully I can last until then, and then give myself a day off. So yeah, let's route the rest of these. All right, so just want to stagger these. So now I'm fairly sure we have a good, I think we have a good scheme going here for routing these. So let's stagger these guys. Yeah, I know this is a little bit tedious, but it's part of the process. B, I put too many buttons here. I think we wanted to use we want to use like 2-unit buttons, right? I think so. Yeah, I think we wanted to use extra wide buttons because for space bars and stuff. So we have 6 on each side, so it's 6 units. So 6 units, we could make either 3 2-units or 4 1.5 units, depending on what do we want. I think we probably want 3 or 4. Yeah, I think so. The puppies. I don't know. Like we basically the question is, do we make this like plank layout or we make this something different? I don't really like a space bar, honestly, but yeah, let's do this. Let's do this right. 1 2 3 4 5 6. So we're gonna just delete these guys here because we're gonna use 2-unit. Use 2-unit keys. Oh. This is gonna make a little bit of a mess, but don't worry. Everything's going to be fine. Everything's going to be fine. It's a little bit tedious, but look, there's a reason why I wanted to make this particular project our first PCB layout, because after all the trouble I've been having with doing CAD live in front of a live studio audience, I want to make sure I can deliver before. I want to make sure I can deliver and actually keep up with the work while doing circuit board layout. So this one's fine where it is. This one's going to go here, and this one we're going to shift over here. Yeah, these are going to be 2-unit to give us sort of like that space bar type thing, kind of like an intermediary between like between the plank or Prionic style, which doesn't have any sort of spacebar. It just has a 5th row of keys, sort of like a kind of bridging the gap sort of thing. Yeah, I like having some thumb keys, especially for the Cyberdeck, which we want to have a few extra functions on file or on deck. Yeah, this is going to be a split spacebar. This is going to be a split spacebar. Yeah, let's rock and roll. All right, so let's move. Yeah, so let's order these. All right. Oh yeah, it looks like people are liking are interested in our doggos. I know a lot of pet owners can't stop talking about their dogs and or their pets in general. I'm trying not to be like that. Yeah. I'm trying not to be like that. I know that there are people who care about pets and there are people who do not. And I want to respect that. Personally, I don't know, like my interest in the dogs is Brooke. Like the dogs matter to Brooke, so they matter to me. There you go. But they're all right. They're good boys. They need training. But we're giving it to them. I've become a lot better of a dog trainer, I'll tell you that. I hope. I'm really worried about accidentally training bad habits into them and then being stuck with them forever. There we go. Let's move this over here. All right, let's get a couple more questions here. Let's get a couple more questions here. We have a few. I think so. One of the things to think about is the future of the streams, because I love streaming. And I know that everyone here obviously is biased, but the fact of the matter is, the numbers are showing that the streams are worse for the channel. Like, the streams are a net negative for the channel. They're actually worse. We're better off not, like, the numbers are showing that we're better off not running them. I like running them, and they also allow me to make videos. Basically, they allow me to do stuff on the channel, like talk about products, lay out circuit boards, stuff that just could never otherwise fit on the channel. Like there's certain things that you just can't make ultra tightly produced 15-minute videos about. And on top of all of that, I'm still struggling to make more than 2 videos a month. Like even without streaming, I don't think we're gonna be able to. Without streaming, we'd go from it being like a giant pain in the butt. Basically, it would go from being a complete death march to making 3 or 4 videos a month to being a massive workload. So yeah, I don't know how we're gonna bridge that gap. Frankly, I think if what I've heard about YouTube is true, you folks would forget about me without the streams. Because, like, they serve a purpose. Even if you don't watch them, they still remind people that I exist. Anyways, that was the thought process. But the fact is, I think they're causing more harm than good, and I'd really like to keep running them. And let me tell you, I have been losing a lot of sleep over figuring out the future of the channel. On top of that, there were a way to give patrons something for their to thank them. But the patron, like, I pulled the patrons, and the patrons all like the idea of me sharing the streams with the world, which is why I've been leaving them public. Because, like, on one side, my patrons are very benevolent and are totally okay sharing with they're totally okay, sharing what we do with the rest of the world. On the flip side, I now am under the gun to produce yet more content because I have to give the patrons something. Oh man, yeah, I'm starting to get angry letters from patrons being like, "Yeah, I bought like I'm helping the." I don't know. I can't use a silly voice for patrons because they're so nice and they're so helpful to the channel, but. Like, I've been getting a couple angry emails, I'm paying for, like, I'm supporting the channel and I'm just not getting anything for it. Like, you said you're going to put up links for, you said we're going to get streams. You're not putting up any links for streams. Like, I'm supporting, like, I want my name in the credits, but you're making, like, 1 or 2 videos a month. And, yeah, it's a real, the few hour, I'm losing the few hours of sleep. The dogs aren't, Mev. And I'm not complaining either. Don't get me wrong. These are great problems to have. These are what do they call it? Like diseases of prosperity or something. Like when people are getting chubby because they can afford all this delicious food. But yeah, disease of affluence. I don't know. Basically, what I'm saying is, like, I'm trying to figure out the future of the channel because the obvious answer is to migrate the streams to Twitch or to a different channel, right? But the problem is, statistically, and this is beared on my channel too. This is like statistically, if you have a really dedicated audience, which thankfully you are, if you have a really dedicated audience, you can convince about 1% of people to do anything, to do something. It doesn't really matter what the something is. Like, it could be buy merch, could be going to, a Patreon, it could be follow you to a different channel, or to a different topic, or watch a podcast that you guest star on, right? You basically get 1% of your audience to do that. And this is a problem. This is a problem because the daily views for our videos in the channel are such that if I can convince 1% of people in a recently released video to follow me to Twitch, like, this is on a per day basis because you have to go to Twitch at the exact time I'm streaming. Basically, I can only drag about 50 people to Twitch, and that's not good because in order to get any organic traffic from Twitch, you have to appear in the top the top of your category. And if we're doing you have to appear in the top of your category. I don't know why I keep typing move, because it's clear that we are. And the science and technology category, the worst performer on the top page generally is around 1,000 viewers, 1,000 concurrents. So without the ability, I'm sorry, not 1,000, 100. So without the ability to draw 100 people to every stream, we're never going to grow on Twitch. and that makes it not worth, it's not worth doing something. It's not worth doing it if no one's watching, or if very few people are watching. So this is a real issue. Basically, in order to move to another channel or to move to Twitch, I'm going to need to make a ton of videos, because we need to ping people over and over to maximize the chances that when they see the call to action and decide to follow me to another, follow this stream to another channel, that they that I'm streaming at that time. Yeah. Part of the fun. It never ends. All right, let's switch back over and make sure that our numbering is actually working the way I think it is. Let's see. So we've got 17, 15, yada, yada, yada. So these are going in order downwards. So, yeah, we're just going to go... Am I doing this the right way? Yeah, because I think we're going to go, like... Are we doing this the right way, or should I be staggering these rows? Man, this is really hard to think through. This is really hard to think through here. Whatever. People don't want to watch me waffling. Let's get back to routing. If it turns out to be hard to do this way, then so be it. That's what I get for not being quicker on my feet. Let's make sure we're... Oh, jeez. Oh, man. I made an extra large Mio to perk myself up. My hands are shaking. Makes it hard to be this precise. Got to get one of those. Remember back in the day, you had light pens. Remember when light pens were going to be the way. Oh, jeez, my hand is shaking too much. We're going to be the way everyone works with computers in the future. Man, I love the old school future. Oh, you can't see what I'm doing here. Oh, you get vault. There we go. Oh man, this is really hard. The schematic is bigger than the schematic editor will allow us to make, so I can't use the scroll bar, so I have to zoom in and out to move. Oh, this is really tough. What else do I have here? Do I have something like, do I still have a trackball? I think I got rid of the trackball. No, it's mouse or bust. Alright. So then this goes here. Yep. Nice and easy. Yeah, don't worry, we're almost done here. Let's see. So we got 3, and now we got the 4th. So now we're starting from now we're on the 30 side. Let's confirm the orientation of those guys. So we're continuing up the other side in the opposite direction. So we need to other side, opposite direction. We need to go in the other, the other orientation. Okay. 31 and 32 are the bottom. So these are going to be the farthest. How many more do we have here? We got 1, 2, 3. We got 31, 54. These aren't going to be in order, are they? 54 minus 31. That seems reasonable. So how are we going to split this up? We got 12 rows, and we got these guys here, which are, so you basically have 14 rows, and we got 14 rows, so I'm thinking that we'll split this to have 8 on one side, 8 rows on one side and 4 rows on the other. So we're only going to connect one more row here. I think I over-designed this. Yeah, I think we might have. You know what? Let's just see how. Let's just stick with our guns here. Instead of this being on the bottom, this is going to be on the top. Yeah, let's see. We're gonna stick to our guns, and I think this is gonna work. And if not, we'll. Oh, geez, I have to get my face out of here. And look, well, we can always make changes. It's always possible. Yeah, the other ones are gonna, remember, the other keys are gonna be on another physical piece of hardware. So we're gonna give those their own multiplexer. So we only need to connect the two with like, you know, I squared C or whatever. However, we bust them together. I'm gonna move this Mio out of here before I drink more of it. All right, so let's save. Do we want to hook this up? Not quite yet. Let's switch over to our. Let's switch over here and let's order the keys. I just realized that we made a mistake here. We should have first created our schematic and switched the grid to be 18 millimeters, so that the keys are automatically placed pre-spaced. Oh boy. So yeah. How do we want to space these? We want the keys to be on a 19 millimeter grid, right? Like, is that how you do it? Well, let's look this up real quick. Because if we mess this up, it's gonna take ages. The other thing is we can't really make any mistakes here because I don't have time to do any do-overs. Like, in order to build this project, I'm gonna have to run full throttle. Have to run full throttle. So basically, if I make a substantial mistake that adds an extra 3 or 4 hours to the project, we're screwed. I'm gonna have to change the entire video. Like, our time is really that tight. All right. Right. So we want to do cherry or kale chalk dimensions. Let's see if it has a placement, like a board placement guide. Let's see. We've got our. So these are the keys. These are the DSA style keys, which we might use. We could also print some. I think we'll start with we'll start with. Oh yeah, look how nice and thin that is. Oh, that's so nice. I think we'll start by buying keys, and then we'll end up printing our own, probably, because we're cool like that. Yeah, it doesn't give any guidance. So let's just go to cherry dimensions. I think we like spacing them 19 millimeters. I'm not 100%. I'm not 100% here. I just want to be careful because I keep messing this up when I do my own mechanical keyboard projects. I realized that through listening to the dogs, listening to my streams, I smack my lips and say and ah too much. I've been trying really hard to cut that out, and I realized I blew all of that by leaving notification sounds on my computer. I'm so embarrassed. Here we go. So this is a rough idea for custom plates. So this is 14 millimeters. Is that right? That seems a little small, doesn't it? Yeah, I think this is wrong. Oh, that's not right. Oh, that footprint's not right. Building a hand-wired keyboard. Come on. Cherry MX spacing, maybe? Spacing dimensions. Keycap size around 18 millimeters. Distance between keycap placeholder space. Yeah, we want 19 millimeters. Yeah. Well, I better learn my 19 times tables in a hurry. All right, let's get this done. Switch back to here. So let's. Oh, it wouldn't even change it anyways. I don't know how it decides what the grid is. So we're gonna change our grid to. So right now we still have it set to be the finest. So we're gonna change this to millimeter units, and we'll set ourselves in a 1 millimeter grid, I think. 1 millimeter grid, alternate size of 0.5 millimeters. We can always change this later. So our switches, we have to be careful here. We could write a script. I haven't wrote a user script in so long, although it probably makes more sense to write a user script to position these, doesn't it? I said again, and then I smacked my lips. I'm the worst. Let's do a little research. Yeah, the to-do list is rough. Or the to-do list the to. Let's see here. Maxtronic says 3 hours in, haven't checked off our first task. Not especially. Oh, what do we got here? All right. Hang on a second. We're missing a couple things. GWR Films, thanks a lot for the super chat. Could you do review videos of Maker Tech 3D printers, etc., or release projects Patreon only? The first one, I found that so in my research of channels, I found that once you start putting reviews, there's the way I've noticed this going on many channels is that when you do reviews, your first few reviews tend to do very well. They tend to be great videos. But then it creates this death spiral where basically, like, it creates this death spiral where people stop watching the review videos and Google stops recommending your other videos, and then the entire channel just starts to underperform. Although it could be a bit of a cargo cult thing, because could be a bit of a cargo cult thing now that I'm thinking about it and like talking, because it could be just they take more review videos as you get less ad revenue. I don't know. I don't think is that something you'd want? Is that something folks would want to see? Because I'm skeptical that review videos would do well unless the products are really exotic. As for projects being Patreon only, I owe so much to the open hardware community. It just wouldn't feel right to lock the projects behind a paywall. It just wouldn't feel right. On top of that, I feel like people would oh, this is it's saving. I've been saving nonstop. Brooke reminded me to save. I've been saving nonstop. I think the quality level people would expect is also beyond what I have time to create. Because like the Chromance, for instance. If I don't think people would enjoy saying like, oh, I want to build my own Chromance, and then give me $5 and be like, oh wow, the way this guy connected all these NeoPixel strips together makes no sense at all. What the hell is I'm paying for this? So I'd have to go back and redo the project to make it worthy of the Patreon or whatnot. It's an idea. I'm also thinking of making things like, for instance, like a for the Every Filament episode, right? Making like a poster of all like the printing temperatures and stuff. That could be something I could hire someone to do. It's really hard. It's tough. I'm working on it. I want to take care of the people who take care of me. Both and not just in terms of money. I think it's just as important to recognize people who contribute to open source projects, if not more so, because I couldn't do what I do without them doing what they do. So let's think here. How do we? So like, I haven't done a ULP. So I've done ULPs before, but not in ages. Let's open up Sublime Text. Let's. I think it's fair to say that we're done with this and we're making our arrow. Sorry if I was bumming people out, by the way. Sorry if I was bumming people out talking about personal stuff. You can see how taxing trying to think this stuff through is. It's very difficult to keep my game face on and to keep on script while also thinking through a PCB layout, while simultaneously routing the PCB, while thinking about like the flow of the show and keeping an eye on all my comms. You can see how that plays out. But look, it's a matter of practice, right? So while we're here, let's move this over to the other. Let's move this guy over here and let's write ourselves a ULP. I don't remember how to do this, so I'm just gonna quickly refresh my memory. Eagle ULP. I'm just gonna quickly refresh my memory on how to do this. Do we want a ULP or do we want a script? This is important. User language programming or a script? I think a script is just a list of commands, right? Man, I haven't done this in ages. I wrote a script to. So one time I did I tried to do like a Charlieplex like clock, so it was like a ring of LEDs, and I wrote a script to position all of those. Yeah, don't worry. Again, we're not going to get too caught up reading documentation. I know it's not fun to watch. I know, I know all that, but I just need to refresh my memory because I remember some of them being very easy. So ULP is like a C-type language. So how do we do this? Eagle SCR. I think that's what we want to do. Eagle script files. I think. What's going on here? My phone is blowing up. My phone is blowing up. We have a patron, Samuel Haggerty. Thank you so much for supporting the channel. I really appreciate it. Makes a huge difference. Thank you so much. I really appreciate it. Right, configuration script. Each time an instance of Eagle is opened, Eagle accesses a configuration script. This is a series of commands. So this isn't what we want. We want a ULP, I think. Yeah, all right. So let's do Eagle ULP documentation. Because it's a very simple script, right? We just want to iterate over our switches and run a move command on each one to move it to the X coordinate is going right, like the X coordinate is going to be 19 times its number minus 6 mod 12, and the height is going to be that mod 24, I think. And that's going to mess the last 6 up, but that's fine. We can we can position those by hand. Oh man! In the meantime, let's take a look at writing ULPs. Oh man! Oh, it's a PDF. Oh boy! You know it's going to be good when it's a PDF. User language. Oh no! Oh no! All right, well, let's write this piecemeal. Let's go to page 68. 69. Nice. Let's see. We want to do 4. Oh no, it's weird syntax too. Oh. All right, let's put this over here. There we go. I set up a new set of snap zones to make it easier to see what we're working on. The for statement has the general syntax for in it. Test increment. There's no break or return inside the statement. Oops, that's not what I meant to move at all. One or more loop counters. The loop, brother. The loop. All right, so let's try this. Do I need to put this in brackets? Oh no, this is just it's just a really weird way of describing it. No, this is just C-style syntax. For 0, what's S block? What's that do? The initializing expression it may also define the scope of variable is valid to the end of what's that? When does this break? This I guess this line is going to automatically break when the when it runs out of array things, like it knows when it's out of indexes. That's interesting. But we don't care about that. Let's see. Okay, so we don't want to start here. Let's see. So we're going to switch back here. What are these numbered? So we're going to start from SW7 and continue to SW60. Wait. Oh, right, because we have plus 6 things on the side, minus 6 because we're using double units in the bottom. There we go. Okay, so we're going to start at 7, and then we're going to continue until 60, right? Yeah. And let's reopen this. For I equals 0, I equals 7. I is less than or equal to 60. I plus plus. Right. Do we use braces? Yes, we use braces. All right. So then for each one, all right. So how do we do variables? Do we need? Is this strongly typed, or yeah? Is this? Sometimes these these domain-specific languages are not typed, even if the language they're based on is, because there are just fewer types of objects. All right, that's not helping. Variable definition. Right. All right. So this is strongly typed. Okay. So we've got int key number equals I minus 7. All right. Basically, we're gonna switch the number. Just make life easier when we're iterating here. Okay. So I want to move. We'll figure out this later. I'll figure this out later. All right, so we're going to do new. All right, int. Or this is not going to be an int, right? It's going to be a float, or is there a vector type? Real numbers. Okay, so looks like our floating point type is real, real x and y. Or let's just do this. Real x. In this case, all right. So this equals. All right. So our x location is going to be the number of the key mod 12, right? To get which position on this it is, times 19, I think. Equals key number mod 12 times 19 millimeters. I hope there's. All right, let's not get too far ahead of ourselves before we start figuring out units. All right, so then the y, right, is going to be. Am I doing this right? All right, so it's going to be divided by 12, right? It's going to be the thing divided by. This is going to be the floor. Is there a floor function here? Yep. All right, so we're going to do the floor function of the key number divided by 12, right? Because we want the row number. And, times 19. All right. So now we need to know, now we need to see how do we run, how do we call built-in functions? Let's take a look. Oh, you have a little super chat action. TKM, thank you so much. I really appreciate it. Screw the review downward spiral. I just found the part number for the Singularitron strap, and I might just work on a wearable computer during my vacay. Thanks for the inspiration. Here's the part number. Oh, cool, cool, cool. I thought that thing was out of stock forever. It was as a replacement for a wearable barcode scanner, I think. And yeah, I thought it was out of stock forever. But oh, that's great. It's a really good part. It's super comfortable to wear. Super strong retaining holding or super strong power. Like sticks the thing to your wrist in a sturdy way and doesn't slip around. It's a really good part. You're very lucky to find more of those. But don't worry, by the way, about the reviews. I've actually have a bit of a backlog here. I have 4 items that were sent to me by review, or sent to me for review, 3 of which paid me. So we're gonna slot those 3 in at some point. The 4th one, though, I'm being very facetious here. The 4th one is actually really interesting. I think I'm gonna do it anyways. Yeah, we got some really cool stuff. It's interesting to hear the people like that, because it's one of those types. Reviews are one of those types of content that I personally don't enjoy watching. So it's hard for me. Like it's important to hear people say they like it, because it helps me get inside your head and help you. Because yeah, helps me understand what you folks like seeing. So let's try to run a command here. How does this work? How do we run commands? Row and column frames. And this is useful when you want to select a text with the move command. How do we do commands? System executes a system program. Status displays something in the status bar. You can sort stuff, but how do we call an internal function? That's a question. We can do constants. Let's see how to program. Oh boy, we have typecasting. UL element, so we can so let's see here. Do we move items by running the move command on them, or do we move items by opening up the object and editing their properties? 'Cause, if possible, I'd prefer not to start getting into object-oriented programming on stream. I have to remember that I'm not that good of a programmer that I can easily read and internalize documentation this rapidly. Okay, don't worry, we will move forward. Let's time box this again. I'll give myself another 10 minutes to have the script finished. If it's not, we'll just put on some tunes and move them all by hand. Have I missed something here? Is there anything to run internal commands? To run eagle commands? We got dialogues. We got HTML tags. Expressions. Built-ins. Built-in functions. Does that help? File handling functions. Character functions. Boy, we can capitalize. File handling functions is not exactly going to help. File name functions. File input functions. All right, so it looks like we're going to need... All right, looks like we don't... Instead of using the commands, we need to just open up the object itself. So how do we access items? The attribute member can be used to query a UL part. I'm guessing UL is user language. For the value of a given attribute, the return string is empty. Can we get it, or can we set it? Are we allowed to set it? Schematic in S. If the part is in a sheet context, the instances loop member accepts. The part is a schematic context. All instances are looped through. All right. So how do we gather the? How do we figure out which are which? Do we identify them by name? Do we concatenate names? Oh boy. Can we here's the thing to check. Can we use the command line within Eagle as an interactive, can we use that as an interactive interpreter? Can we test within Eagle itself? S.parts of P. What does this do? I might be in over my head here. This is pretty heavy on 5 hours and some change of sleep. So how do we get parts? Part name, max recommended length of a part name. The attribute member can be used to query a UL part. If any part in the net can be placed outside a frame, valid parameter names. All right, that's not helping. Instance, is that what we want? We want instance. The UL gate has been derived from an instance. What's this? It's not even telling me what that is. Oh, this is great. It's not even telling me what the objects represent. Oh my. Oh my. Object types. The data files contain a hierarchy of objects. In a user language program, you can access these hierarchies through their respective built-in access statements. These access statements set up a context in which you can access the objects contained within the library, schematic, or board. The properties of these objects can be accessed through members. You have data members and loop members. Data members grab requested data from an object. For example, this. The data member returns the name of an object B. Loop members used to access multiple objects of the same kind, which are contained within a higher level object. This example uses the board elements object to loop through all the board's elements. So how does this work? Creates a variable of the type necessary to hold the requested object. You're free to use any valid name. Oh boy. Right. Object hierarchy of a board. Here we go. Board, grid part, whole frame, text, element. Is that what we want? Is that what we want? We want an element. Used to query an element. All right, that's what we want. So we want to pull up our elements. Let's see. Board. All right, so this is a multi-line comment. So even if we can use this in interact, maybe we can use this in interactive mode. Look, we're about to find out, right? Let's move this over to this side, and let's put this over here, and let's give this a shot. Board B. No, we cannot. We have to write full scripts in order to test our commands. Oh boy. So if we do a printf, where is it being printed to? Let's see. Let's just run the example code and see what we get. Like, where's printf printing to? I just realized, are there imports or something that we have to do? Oh boy. Right. So let's save this as. Let's throw this on downloads for now. Actually, let's put this in. No, not the stream video. I can't believe I have to edit video after this. Oh man. After the stream is finished, I have to jump right into Premiere and cut the rest of our video. No rest for the wicked. Projects, active projects. Where did I put this? Cyberdeck v2, Metkeyb, key, arrange, test, script. Key, arrange, test, script. .ulp. No, I'm not going to purchase this. It's like WinRAR. Right, so let's run this. Maybe I want to edit this within the ULP folder, because then they're gonna just change it to be named test or something. Yeah, that's a mistake. All right, let's do this over here. Let's go to. Let's save as again, and we're going to save this as test.ulp, and we're going to save this. I completely forgot where we saved this. So let's see. Eagle ULP. All right. So we're going to go here. We're going to go to C. Eagle. Oh. There we go. All right, and let's just see what happens here. Run test.ulp. Current drawing is not a board. How do we tell it? How do we tell it what? How do we run a script? All right, so there's we have to tell it somehow the script can run in boards. Oh, because we're invoking the board command here. So I'm guessing that only works if we currently have the board, if we run it from the board viewer, because ULPs can be run from both of them. Run board, or run test.ulp. Call to printf without an output statement. All right. Welcome. Oh no, it's programming. You know what? The fact of the matter is, I have to get this done. So I know how folks feel about programming, but I think you folks that like programming, you finally get what you want. For the next hour, we're going to be doing boring programming in all of its boring glory. Because the fact of the matter is, I really got to make as much progress on this as possible. So we have to assign some sort of output. Printf. Alright, where is this defined? Oh my gentle Jesus, look at all of these. It's in a PDF, so like there are no hyperlinks. Data members. Okay, how do we use this? Oh my friggin' gosh. Page 89. Printf. Returns number of characters written to a file. Output. Opens an output file for subsequent printf calls. Alright. So we need to run, I'm guessing, output test output.txt, and the type is, what's it? Oh, we have to nest this? Print text. Output statements can be nested as long as there are enough file handles available and provided no two access the same file. Alright, how does this work? So we have to wrap the printf call in an output. Okay, so we want to write mode, and T is text mode. Create an existing file. Man, I'm going. I think I might have to call this one just because I don't have the brain power to process this. Oh, we have a super chat. Thank you so much. Tevla, we don't all hate code. I know Tevla is a code lover. I appreciate your support. Thank you very much. Hey, let's look. It's got to be. It's the nature of a hardware hacking channel in which we do programming and code and and 3D printing and modeling and talking about the business aspects of it. Like, there's going to be elements that some people don't like. It's the nature of the game. Unfortunately, I wouldn't be able to produce anything if I had to cut something. If I had to like pick one part. Like, anyways, I really appreciate it. Thanks a lot for the support. It means a lot. The order. Most characters can appear in any order and combination. However, only the last of W or T or B is significant for order. Oh, for crying out loud. All right. Is this append? Yeah, we want to do an append mode. Yeah, so we want to do AT mode, and these are not. Oh, this is a string. All right, so this is C style. And I have to wrap the rest of our code in here. Save this. Let's open up. Where do we put this? This is going to end up in the Eagle folder, right? Yeah, it's going to end up in the Eagle folder. So that was C Eagle. Oop. And it's going to be, I forgot what did I name this? Something test? What did I name this? I named this test output. Where the hell did this go? Maybe I can search for it. Test output.txt. Oh, it's in the new project that I created that I don't think we're using, I think. Oh, for crying out loud. All right. So it looks like we got some test output. Let's open this up in Sublime Text. All right. So this gave us a list of elements. The question is, how do we collect and iterate through oh man, this is a site where I passed our deadline, although, oh my man. Okay. I'm doing too much whining, not enough routing. We have to solve this. I have to figure this out. I have to do it right now. I haven't checked chat in a while. Let's take a quick detour and oh hey, Trevor, thank you so much for the super chat. Code is life. You're doing fine. Thank you. I really appreciate it. Code. It is. It's part of the process. Albero Alberto, thank you so much for the super chat. Not much, but at least you can get a coffee. Oh man, my hands are practically vibrating. If I get any more caffeine in me, I think my heart is gonna explode. Tell you what though, I'm gonna quickly head in here, and I know everyone can hear me. I'm gonna grab myself a little water because it's important to stay hydrated. Yep. Anyways, I haven't mentioned in a while that today's episode is sponsored by Next PCB. And yeah, if you want some pretty high quality PCBs with great prices and fast service, then go ahead and check them out. They're running a sale right now. You get 20 to 30% off, which is a big deal. Some cheap boards, and their service can be really fast. And then you get like a 3 to 5 day turnaround. It's nuts. Use the link in the description. It helps the channel, and it helps the channel. It helps you get your project done faster and better, and save a bit of money there. Yami Industries says, I want to DIY stuff like you. I can't afford it. Are there projects that are easy on the wallet? This is tough. This is brutal. This is brutal. Yes, there are a few types of projects that are easy on the wallet. I'm going to say this we're going to try to do the impossible here, and I'm going to talk while reading, because that's a skill that I got to pick up if I'm serious about doing this job. Some projects that, right, you can try more crafty projects, things like sculpting, things like sculpting, making clothes, just doing stuff that's less technical, because the material there and the tools are fairly cheap. You can try something like 3D printing, which has a high setup cost, right? Like, you have to buy the printer. That's fairly expensive. But past that point, it's, there's plenty of free CAD software, and the plastic is very cheap as well. Depending on where you live, again, I can't account for literally everywhere where literally everyone lives. In most places, plastic is cheap. So if you can save up for a few months and get a 3D printer, then you can get plastic fairly cheap. That saves some money. You could do a similar thing, but with knowledge. Like, for instance, you could you could shell out a bunch of money on decent electronics tools and to learn electronics, and then do stuff like salvaging and hardware hacking, where you can work with a lot of cheap stuff. Unfortunately, this is a very expensive hobby. There's no way around it. I'm very lucky to have the privilege to be able to actually do it, and I try to make it as accessible as possible. But at the end of the day, it's an intrinsically expensive hobby. You pay, if you're not paying money, you pay time, and the amount of time can be significant. Like, trying to build electronics without an oscilloscope or without a high quality soldering iron is a nightmare. Like, trying to learn electronics, having no ability to buy a training kit or, to get a proper multimeter, it's going to be brutal. Like, at the end of the day, if it's a hobby, do what you want. But, okay, so let's see what we got here. So in board, yeah. So by nesting, this is such bizarre syntax. This is such bonkers syntax. So we get our element, E. And how do we sort this? Do we just do if, like, e.name equals this? Then I guess that's what we have to do, right? Yeah, I guess that's what we have to do. Test.ol. So let's see. So here's, let's put this together. Right. So we've got, all right. So let's wrap this in our board. I think I don't think we needed to write this way. Okay. So, reposition.txt. Right. So instead of right, instead of printing the name here, oh, we get auto indent. It recognizes it as C-style syntax. Oh, at least we can tell it to. You are now C. Ah, look at that syntax highlighting. So nice. Okay, so if of, let me just double check that the if syntax is the same. No reason to believe if, else, if, else. 69. Oh yeah, page 69. Alright, so it's just your standard. Okay, if e dot name, can we use comparison on strings? Equal sign, string compare, string, command? How do we do this? String, comparison, comparison operators, 63. 63. Comparison operators. Evaluation. Evaluate expressions based on a condition or group a sequence of expressions to have them evaluated as one. The advantages of condition. So this is how to do the ternary operator. String operators. The question is, can we compare strings using equality? Or do we have to use a special string.equals expression or string comparison? Nope. Scans a string with the first occurrence of a character. Join a string array. Calculate the length of a string. Convert uppercase. Last occurrence. Scans a string for a substring. Split a string. Extract a substring. String to converts lowercase to uppercase. All right, so it looks like we just like run a string comparison. Okay, next thing we need to know is how do we cast? How do we convert an integer to a string? I to substring from a string. Convert a string to an integer. We want the opposite. Stir to I. Stir to L, or is it an uppercase L or? I guess, do we just like concatenate? No, the word concatenate. String constants can be concatenated by writing them next to each other. Okay, but can we, how do we typecast? Do we have to cast it? Typecast, where type is the result of char, int, or real, the expression type conversions. Is that what we want? Resulting type. So how do we get a string from an integer? How do we do that? How do we get a string from an integer? There's no string comparison. String character scans a string for the first occurrence of a given character. All right, so we have to search for this. So eagle int to string. Eagle convert a real to a string. You go the other way around. There's string to D. But there isn't an equivalent D to string. You can do it with sprintf. Okay, so this isn't possible. So how do we identify? All right, so then how do we perform operations on specific? All right, let's think here. How do we? Okay, so we can't do. How how do we search by name, right? Like there's no, like, how is this a first class, like, this has to be a first class feature, right? Like there has to be a way to iterate through parts and operate on them based on their number, right? Right. Elements. UL element 33. There we go. UL element. All right. Name is string, but how do we? But like, how do we run math on that? So there's no way to convert a string. Print F. So we have to print it. The other way around, there's a string to D function, but there is an equivalent D to string. You do this with sprintf, but it's not helpful. You want to convert a value in place within another statement. So what I've done is write my own library, which includes things like this. All right, so is this eagle switch on part number. How do I do this? I mean, I guess we could do this the other way. We could split the part name into a substring on SW. And we split the part name on SW and then convert that. I think that's what we have to do. Split, stir, split. Okay, split a string into separate fields. All right. Extracts a substring. All right, so let's see. So we want to do stir. Scans a string for the last occurrence of a given substring. We want the first, right? Right? Yeah. Not character. First occurrence of a given character. I think this is stir rstr or stir str, I think. Right? Substring. All right. Okay, so here's what we're going to do. Substring. Okay, what does this do? If index is given, returns the integer offset of the first character, or -1 if it does not occur. Okay, so here we go. If stir substring ename. All right, so let's see. If ename contains SW for switch, right? Then let's see. We're gonna do int switch number, or yeah, switch number equals So can we do anonymous functions here, or oh man. All right. I'm sorry for all the radio silence, by the way. I'm thoroughly mentally overloaded here. So yeah. I gotta face facts. This is not an entertaining stream. I'm really sorry for everyone who's still here. Piss. Let's see what Brooks. Let's check in. I haven't checked in a bit. Nothing coming from Brooke. I'm sorry for making this so unentertaining. I really am trying as hard as I can to keep up the banter while figuring this out. But this is really cranking my noodle here. This is tough stuff. Let's put this to a vote. I want to hear what you have to say. Should we continue? Should we quit and do this manually? Should we switch to something more interesting? We could run a 3D print. We could we run a 3D print. We could like play a game. I could take questions, or should we can it for the day? Any thoughts? Any thoughts here? Seems like people are. Seems like folks are into it. All right. For now, seems like folks are into it. All right. So let's keep on rolling. Slowly knocking my my mic body pack off. I'm shifting in my chair all the time. Beefing it says, wouldn't mind more obvious coding steps, like letting us know what's going on more. It's really hard because like I don't know what I'm doing, so like it's hard to explain it because I don't know what I'm doing. But yeah, let me recenter. You know what? Maybe we should disengage for a second or two and just recenter myself. All right. So here's what we're doing. We have 60 switches that I'd like to just write a script to reposition, right? We've written code to collect the names of all of our parts. Now we need to select the ones that correspond to switches and get what switch number they are. Switches 7 to 60 correspond to the buttons we're trying to move, switches we're trying to move around. So we need to extract that number from the part name and then just figure out what position we need to go from there. So all right, so what we need right now is we need substrings. So this is going to be of type, so right, this is going to be of type string. Is it called string? Is it called stir? All right. I'm sorry about the ums, by the way. Substring scans a string, but now we want to extract the substring. Returns the substring indicated by the start. Oh, I mean, this is fine. Yeah. Oh, okay. Oh, all right. I'm overthinking this. I'm overthinking this. So the switch number is going to be what is it? A2. What's the string to? What's one to convert a string to an integer? String split. Is this an lowercase L or is it an uppercase I? This is a lower. Why is this an L? Represents the numerical representation of the given string as an int value. I think someone was like copying this from C++ and they saw string to integer. str2i, and they thought it was strto lowercase l, because it's the only explanation I can think of for this. All right, so we got string to I, or actually string to l, and we want the substring, right? Str sub, not substring, it's string sub. str sub, and we want everything from, it's called swx, so we want everything from e.name from 0, 1. So is this inclusive? The value for length must be positive. So let's see. So t equals. So this is a string. We got 1, 2, 3, 4. Oh, it has example code, but it doesn't show what the example code does. You actually have to start your own script and figure it out. So it doesn't say whether this is inclusive. So yeah, I think we're gonna say this is inclusive. Yeah, Spencer, thank you so much for the super chat. Howdy, Zach. Thanks for all the hard work you put in to share your projects. Content's entertaining and informative. Thank you very much. I really appreciate it. I try very hard. You should see what we've been doing with all this 3D printing. At this point, I've 3D printed basically every material that exists. It took a bit of work, but I've learned a lot about 3D printing. This is why I'm so excited about this one. We're going to get back to actually doing projects. I know it's been a little too long since we built projects. I got a little too caught up building the tool changer and then doing this every filament thing. It's really exciting. I'm enjoying it. I'm learning more than I ever thought existed. But I know we got to get back to building projects. Pugs or Epic says, "Are you ever going to do a project that?" Thanks for the super chat, by the way. You ever going to do a project involving a neural interface? Probably not. Maybe, I don't know. On one hand, it's a manageable project. On one hand, it's a manageable project. right? Because it's really only a couple things. On the other hand, they tend to be very, what's the way of saying it? They don't work. That's a good way of saying it. They're baloney. So actually, making it in a way that's stable enough that we can actually get it on camera and shooting it in a way that proves that it's working and it's not somebody mechanical turking it behind the scenes, I think it's going to be tricky. But we might, yeah, could be possible. I don't know what we do with it though. Like, yeah, brain computer interfaces are both, they don't really give you a lot of meaningful information and they don't work. So yeah. Okay. So yeah, so we got our switch number here, and oh, let's just do this. Let's go to our let's switch this to key number by subtracting 7, because the first switch we care about starts. Oh, wait, hang on a second. Yeah, here we go. So here's what we care about. If the number, so basically, all right. So what I'm writing now is, by the way, let me know if I'm explaining this properly, because I don't have my thoughts aren't very structured when it comes to coding. I'm basically throwing stuff down and checking if it looks right. So right now what we're doing is so switches 1 through 6 are going to be the OLEDs. We're not dealing with those yet. We don't need to position those. We'll do that manually. The ones we care about are 7 through 60. So we only care about, so all right, so if, let's see, if the key number is greater than equal to 7, then we want to move this thing. All right, so key number minus equals 7. Basically, we want to index these at 0. So we can want to index these at 0 so that we can run math on it. Let's get that in here. Man, we're losing our parens. Okay, we're losing our indentation here. I'm losing track of where we are. Okay, so we're subtracting 7 from it. We got our x value, basically what row it's in, is going to be mod 12, right? Because it goes left to right, left to right, left to right. And our y is, or like our row, or our column is going to be mod 12. A row is going to be divided by 12, because there are 12 per. So multiply by 19, because we want this to move 19 millimeters. Hopefully this is going to work. And AJ Cody says, maybe showing pseudocode on the screen would help people follow along. What? This is the code. This is the thing. That's what we're doing. What, am I going to write code twice? Yeah. I'm completely derailed now. All right. So now we have our x and y. Let's. So does the unit matter? That's the next question here. Ex and ey. Let's take a look at the dump from our previous test. So this is some sort. So what are the units here? This is our. Oh boy, this is our x and y. So let's find out what this is. Probably some sort of device agnostic, like some sort of unit agnostic numbers. Christ. What are these? What's this data type called? It's called element. Element.x. This is on page 33. Element, x and y, integer origin point. So what unit is this? This documentation blows. This is terrible. This isn't even close to the worst I've ever seen. Not even top 10, but this is bad. This is rough stuff. Oh, man. X. Man, the script should not have been this hard. Fuck, this is so hard. This documentation blows. What the hell unit is this? Oh, man. Implementation details, type conversion, object types. What the actual hell? Maybe this is going to be found near the word origin. The coordinates are always those of the gate's position within the device. Not helpful. What units are the origin? Eagle ULP coordinate units. A macro? Should I have just... Did I make a mistake here? Was I supposed to do a macro instead of a ULP? Oh, man. Have I been doing this the entire wrong... Have I been doing this wrong the entire time? How is this not higher? How... The position of components on the board is literally what every script works on. How the hell is this not higher on the searches? What the hell is this? Oh man. Has anyone done this before? Let me check the let's look at chat. Has anyone done this before? Like, what units do ULPs use for X and Y? I'm getting emailed. Oh, we got some patrons. Jack Dealey and Cecil A. Thank you so much for becoming patrons. I really appreciate it. Your support is much appreciated, and thank you very much. You folks are very generous. Yeah, I think the smart thing to do is we're just going to run into problem after problem. We should give up. We should just go back to positioning this manually. Oh, man. Oh, for Christ's sakes. Auto Drop 3D says, why not just run it and measure? This is the output of a test script that we ran on. Let's find it. This is the output. So let's think. Maybe there's a pattern here. This is the output of the script we ran right here. Right here. This very document, this exact window. Look, I'm going to hit the up key. There we go. The command that shows up is run test.ulp. We are currently in millimeters. I have a hard time believing that these switches are 6 kilometers below the origin. This is, by the way, the difficulty of doing this manually is going to be pretty far up there. I'm going to have to do my 19 times tables in my head. Oh my god. Alright. I'm going in circles. We're going to lose We're in circles. We're giving people a bad time. I have to decide right now. Either I crack this on the spot or we do this by hand. I'm going to spend... Alright. It's currently 4:20. It's currently 4:23. We're going to give this 120 seconds more. 2 minutes to see if we can figure out what units this are, because if we can figure out these units, the script is just going to work. We're done writing. The logic is set. We're done. All we have to do, and hopefully, I just realized, like, hopefully we can edit these. Like, hopefully this is bi-directional. We can read it and write it. Could these be microns? That is an interesting question. I don't think so. I think these are some sort of device-agnostic unit. Jesus. Let's look at this one. This is switch 8 and minus 20.32 in millimeters. Minus 174. Let's look at the grid. Or gird. I typed gird again. Gird. Inch. There we go. Yeah, so this one minus 0.8 minus... Holy crap. Position these like... Position these badly. Alright, point is, this is 0.8 in inches, and the x is 0.8 in inches, and in millimeters, it is minus 20, or 20. So let's see here. Let's look for SW8. There we go. Neither of these has anything to do with either of those units. So, yeah... Numbers are missing the decimal from where? Like, what are the units? Like, all right, enough is enough. We wasted a bunch of time, but we are better than the sunk cost fallacy. So let's scrap that script, and let's do this all by hand. All right, so let's see. We're gonna move. So we're just gonna move. We're just gonna start at the origin. Let's just make sure. Yep, our units are millimeters. Why is it going 0.9? Oh, rounding errors everywhere. So we're gonna move switch 7. That's the first one. Cody Clemens says set 19 millimeter grid in temporary origin. Might be able to do that. Hang on a sec. I might be an idiot. Yep, I am certainly an idiot. I forgot. Yep, I'm super duper dumb. I forgot that by hitting control, you can force an object back onto the grid. Yep, I just wasted hours of everyone's time. Alright. Well, crap in a hat. You see what I'm saying? Like, it's hard to talk, think, plan, and operate at the same time. Alright. Let's move. We're on a 19 millimeter grid, right? So here's what we're going to do. We're going to move switch 7, right? And which is the one that, you know what? Switch 7, we're just going to put in the origin, make our lives easier. But switch 8, what is the combination that puts it on the grid? One of these. Control, Shift. One of these puts it on the grid. Did this just work? 19 millimeters? Yeah, I guess it just worked. Wait, well, why? It should be moving in increments of 19 millimeters from its current position. But it's not. Well, that's bizarre. That's really weird. Well, I am sorry for the mess then. Crap. I could have. Now that time was wasted. This is why we don't do the sunk cost fallacy. This is why we watch out for the sunk cost fallacy, kids. This is why we test our. That's why we never cut corners, and we always, always, always test our assumptions. Cody Clemens, you are on point. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need 3 more. 16, 17, 18. 3 more. 1, 2. 12. Yep, there we go. And we ended here at switch 13, I think? Yeah. Or, for Christ's sakes. This is switch 18. All right, so let's start over. Just want to check our assumption again. Switch 6. Yep, that's our last clicky one. So yeah, so we're just laying this out in a grid. We're building our keyboard. Building the keyboard. This is why, by the way, this is why learning the scripting languages for the software you use often is so important, because it can save hours and hours and hours of time. Down the line, yeah, switch 19. Yep, switch 20. Yeah, you'd think that at some point in making all those dozens of projects with Eagle, I would have spent a few days learning. Would have spent a few days learning how to write scripts, but in that case, you would be wrong. It's the nature of the game. Honestly, yeah, it's my greatest weakness, you know? My greatest weakness is that I'm not a very fast coder, so teaching myself new coding stuff is a real imposition. But yeah, let's get, let's lay all of these. Let's take a look at the, yeah. An astrophysicist Jason says, why they have the print F like that in the docs is beyond me. These docs are, they're not even close to the worst I've seen. And, like, I get, like, you know, let's be, like, I have to be level. Like, I'm being a giant whiner. A more competent programmer would have been able to figure this out much quicker. Yeah, look, we got to take our licks. Look, at least we're back in the running, right? The important point is the project is getting done. The important point is the project is getting done. All right. And then we'll do a little more wiring. I didn't want to go much further with that. Like, I didn't want to go much further than this without checking that we're doing this right. Oh, right, we already routed half the friggin' board. That's why we stopped. 4950. 1, 2. Switch 53. Switch 54. Yeah, this wasn't worth it. Halfboard says Zack Cranky Pants today. Oh, I'm sorry about the attitude. I'm really sorry. I'm trying as hard as I can to keep my game face on. Oh man. All right. So we no longer want to be on a 19 mm grid, right? We want to be on on half of 19 mm. 19 over 2. We want to be on a 9.5 mm because we are doing double unit keys. Sorry, I 9.5. Yeah, I'm trying to. I will be more. Another one of my greatest weaknesses is that I don't have a lot of experience working in the service sector, so I'm not used to putting on my game face. I gotta, I've only been doing this channel for like a year. Like I've only been in the media industry for like a year. This is it. Number sanity check complete. Number 60. There we go. Let's save. All right. Let's save. And let's move the other switches into position too while we're at it. Yeah. So how do we want to do this? Let's think here. So how do we want to do this? We got 5 rows. So that's 19 times 4, because that's the distance middle to middle, so it's about 80. So let's change our grid to around like, and the how here's another thing, like how big are the, oh Jesus, the OLEDs, the OLED module here. I have to check. Let's see here. Have I missed anything? I don't think so. Yep. No, we're good. Close this. Alrighty. So these are 12 millimeters. So let's put ourselves in a 13 millimeter grid. Millimeter between them. You think that's enough? Maybe we want more, because then we can. Yeah, maybe we want more. So we want 2 millimeters between them. Let's go on a 14 millimeter grid. All right, and let's move switch 1. We can always rearrange these later. Switch 2. Switch 3. Oh. Here we go. If this comes together, this is going to be really cool looking. This is also going to be the most screens I've ever put on a device, which is a record that I would love to break. That is a good record to fight for. I use Arch, by the way. Says you're writing your own firmware. From my research, we're going to be doing it sort of halfway. I'm going to be using QMK, but I'm going to write my own matrix.c. Basically, writing my own drivers to read the keys, because I don't want to use a matrix. I'd rather use an I/O expander. Pardon, for a number of reasons. All right, and we want to move our jumpers the same way. So let's go into Jeep. Whoop. These represent these represent the OLEDs themselves. Let's make sure they're oriented right. Show ground. Ground should be the top. All right. So we're moving these wrong. We're going to turn these around. All right, so these are our OLEDs, because we're making OLED buttons. We're going to have Stream Deck style buttons with displays on them. You can press the entire screen to click it, and it'll work. Yeah. Check that out. Let's move jumper 3, jumper 4. Yeah, I'm using headers to stand in for the OLEDs because time is tight, and I don't want to start designing custom footprints. Got to pick your battles, right? All right. So here's the Keeb. Pretty good start. These are actually, I think, too close. Let's see. So these are what, like 38 millimeters? Yeah, 38, give or take. So this is what. Let's change our grid back to 1 millimeter. Let's just dimension out a 38 millimeter line. Oh. 38 millimeters. There we go. So I'm just going to grab all these and move them a little this way. Close enough. This is going to be on the bottom, and we should have fairly easy to route arrangement here, right? Should have fairly easy to route, unless I'm... alternately, I made a huge mistake, and this is going to be a total nightmare to route. I think I might have made a huge mistake and made this a nightmare to route. But look, we'll do our damnedest. I'm gonna position this over here. We're gonna rat's nest to organize everything. Let's do a little routing just to make sure. So we're going to start in the bottom. We're gonna route some of these. I can't mentally convert from. Oh, I can't mentally convert from mils to inches. Oh man. Richard Slaughter says, "How long do you think it will to build?" I don't. Well, I mean, look, we're limited to 1 week, so it's gonna take 1 week. If we're not done in a week, then the video doesn't happen, and yeah, I'm in breach of contract. So there you go. Eris Pump says the keyboard's getting kind of huge. I mean, we're dictated. Like the size of the Cyberdeck depends on the size of the screen, and we figured that the screen is going to be about 230 millimeters, give or take, on one side. So let's just sanity check here. Geez, my hands are shaking too much. So let's just sanity check here. This should be in the neighborhood 250. Yeah, because we're gonna have a bezel around the thing and the place and the guy and the thing. We're gonna switch back to inches here to route. We're gonna route on the bottom. We want 45 degree. We're gonna switch over to 0.12. So, did I math wrong? Yeah, we can't fit these in between. So, alright, we're going to make this easier to route by rotating this by 45 degrees. Means we will have fewer overlaps that we have to do. I actually want to do this in the other direction. Minus 45. There we go. I think this will make it easier to route this. And yeah, we can route more or less. Let's see. Brendan Eisner says, "Why are you not using an auto routing program?" Auto routers can't be trusted. They make stupid mistakes, and yeah, they make dumb mistakes. I mean, we could try. So there are two problems with the auto router. First problem, they make dumb mistakes. They're really stupid. The second problem is the auto router can't connect the nets for you. Like it can't, as far as I know, it can't wire the pieces together. It can't wire the pads together in a way that reduces the total length of traces. It can only figure out how to move traces you already did. So the hard part is that we thought did. Still, the hard part is figuring out what key to go to which I/O port. BFingit says, Zack, oh boy, if you considered A/B testing with thumbnails and video titles, oh boy, this is one of those tasks that I just do not have the time to do, and I know it's destroying the channel. The fact of the matter is, like, I wake up, I build projects. I cut, I shoot stuff, I cut video, talk to sponsors, walk dogs, hug my wife, and then it's 6:30 in the morning and I have to go to sleep. You're right. It totally would. I just don't have enough hours in the day. I know it hurts me a lot knowing how much I'm leaving on the table. It's one of the most stressful parts of the job, knowing that I'm not playing the game as well as I should be, but I'm doing everything I can just to put enough content, just to put enough gigabytes on YouTube that we can, pay the rent. So at some point in the future, yes, we do need to optimize our thumbnails. Every once in a while, I'll have 15 minutes or so, and I'll look through the videos to see which ones are see which ones click-through rates are underperforming, and slap together another thumbnail. A lot of our videos, like arguably the channel took off because I improved the name of the Among Us. So basically the Among Us video, I was like, I made Among Us's worst tasks, and the video was total butt, performed terribly. And I changed it to I 3D printed Among Us's worst tasks, and the video erupted. So yeah, he's totally right. It just takes time and diligence, and I don't have either. All right, let's run the auto router and look at the damage. I never even used this stupid thing. I don't even remember how to invoke it. Where is the auto router? Tools, auto router. Oh, it doesn't contain the module. I didn't pay for it. That's true. It was like $1,000. Yeah, it erupted. Yeah. P. Finkett says maybe you could pass off the management work to someone else. I mean, the pandemic's as people get vaccinated, they're hiring Brooke. So my only out is I actually have fewer hours to go around. The channel does not make enough money to pay a second person's salary. I can't have staff. The channel makes enough that Brooke and I don't have to worry about being out in the street if we miss a month. But we can't start paying other people's salaries. It's not even close. So I would have to dip into savings, and that would put us on a really aggressive burn rate. I'd basically have to bring the channel, if we hired even a single person, we'd have to basically triple the action on the channel within about 6 months, which is inconceivable. Yeah, part of the fun. So let's see here. So we've made some mistakes while routing this. I never end up doing as much on as much in these streams as possible. Try as hard as I can, but So I'm just gonna try to route a few of these and see how we made out. I'm not I know these are overlapping. I just want to get an idea of how our routing scheme is working. This is kind of a mess. So the idea here, actually, yeah. I mean, yeah, because we're gonna have wires going. I made a mistake. I made a mistake here. I sorted them. I sorted them by basically by column, when I should have sorted them by row. Now the columns are gonna overlap. Basically, the thing we want to avoid, the thing that can really screw us, is if we have to have too many wires cross. Because there's a limit to how much we can actually do here. Yeah. Yeah. Anyways, all right. You know what? It's too late. I wasted too much time messing around with the script editor. So. Yeah, you know what? I think we're going to put this on hold for now. We're going to pick this up on Monday. In the meantime, I am going to do some thorough planning and figure out a sensible way to wire this up so that on Monday all we're doing is routing or auto routing, depending on how we feel. In the meantime, we can answer some Q&As. Pardon, we have some interesting stuff coming up. Are we picking this up on Monday? I'm not sure we're actually picking this up on Monday. I think we might be showing off a They might be showing off a 3D printer. So yeah, upcoming stuff. We have another resin printer. This one's pretty neat. We got the Anycubic Photon Ultra to show off. We're going to be taking a look at that. We're going to be taking a look at the Anycubic Photon Ultra. We're going to be... Let's see what else. We've got a Revo something or other. Revo Point 3D scanner. We're going to be Brooke and I are going to 3D scan each other, and we're going to put ourselves on the internet. That's going to be fun. We've got a Biku something or other. It's like one of these... It's one of these like Ender clones, but the value... But like the size of the thing for the price is bananas. So we're going to rip that apart and see what the downside is. We have some 3D printed headphones. It's really cool. The company is called Hedamame, which is a neat name. And yeah, basically they send you a kit of parts and you 3D print the rest yourself. You 3D print your own headphones. And we're going to do that live on stream. I pre-calculated all the time it'll take, and we can actually do everything, like from soup to nuts. By splitting the job between our 4 printers, we're actually going to print a set of headphones and assemble it live on stream, which is pretty neat. They do some neat stuff for like they intentionally like reverse a couple. They intentionally reverse faces to expose infill, so that acts like basically sound baffle. The whole thing's really cool. Next PCB is also it's also helping us finish this project. That's going to be really cool. Yeah, they're helping us finish this project. We got a lot to build. We got a lot to do on this project. The mechanical keyboard part is only one aspect of it. We're going to build a mechanical keyboard. I don't know what we're going to do for the batteries. I don't know what we're going to do for the batteries. I'd like to make it use off-the-shelf batteries, but I'm not sure it's like USB power banks, but I'm not sure it's practical. But we're going to have that. We're going to have the CM4 module. We're going to have the keyboard, the CM4 module. That part is going to be cool. We're going to have slots on the back to mount our Singularitron cartridges. That's going to plug hopefully directly into the monitor. Fitting all this stuff in is going to be a bit of a challenge. That's going to be fun. Yeah, good stuff. we're going to be fun. We're going to be there. Yeah, we got a lot of cool stuff coming up. I know that the last few streams were terrible. Let's be honest here. I got a little. Yeah, the 3D printer project has been like every 3D filament project was kicking my ass. So the streams were awful, but that project's done. We have printed. You want to see it? You want to see this? It's really impressive. This is, I think, 85 3D printing filaments, all kinds of exotic materials. We got support-only materials, high-temperature materials, environmentally friendly, environmentally unfriendly. And we're also in talks with a potential partner who could send us another 15. So that's all done, except for those ones. It's all done. So we're just recording that episode. Next episode is going to be about our printers. I realized I've never really shown off the printers. Some of you have sat through as I built them, but apart from that, so that's what the next one is. It's going to be pretty. It's going to be pretty fun. We're gonna have a lot of cool stuff going on. So yeah, thanks to everyone who watched, thanks to everyone who contributed, and thanks to everyone who supported the channel. Even those of you who are not here, we've had our patron names scrolling in the background this whole time. This would be a real problem without you folks. So thanks to everyone. Thanks to everyone. Yeah, we're working, and yeah, by the way, I just want to say, I feel like I know the rate at which we've been producing content hasn't been great, and the rate and like the streams have been we're a little sus. That's the end. We hit a pinch while I was struggling with all those filaments, but that's it. It's projects, cool stuff. I'm improving our technique and our equipment to get more videos done each month. I'm planning the streams out better. This one had nothing worked the way I wanted it to, but we got good stuff coming. Don't worry. we hit a rough patch, but we're going to make stuff better. Thanks a lot to everyone. Thanks for your patience. Thanks for watching. Thanks for supporting, and I'll see you in the future. I should really open up this window before I sign out, because now it's really awkward. It's like when you say goodbye and you walk your separate ways, or you go to walk your separate ways, but turns out you actually have to walk the same way. Yeah, anyways, bye-bye.